training on structural equation modeling. So I would like to highlight that the approach of our webinar is not mathematical. I will not deal about equations. I will not discuss about the derivation of the formulas. Instead, let us explore the the applications of covariance-based ECM and PLS ECM in research. So our approach is non-mathematical, non-technical. So we will focus on the application. In particular, we will answer the question when to use covariance-based ECM, when to use PLS ECM, what are the differences between the two, and of course, we will answer the question how to carry out the computation using software, particularly AMOS and WARP PLS software. Then, of course, let us focus on how to interpret the results, then how to present the results when we write our manuscript for our publication. Okay, so please, because I believe that the audience, the participants of this webinar are not all major in mathematics. So that's the reason why our approach is non-technical. So maybe if some participants are interested about the derivations, the mathematical presentation of the mathematical or complex equations, maybe that would be another level of training. So for now, our focus would be on the applied aspect. Okay, so we will this is our plan. For day one, let me share to you the overview of path analysis. So I will walk through, or let's try to understand what is path analysis, confirmatory factor analysis, and structural equation modeling. Then later, if we still have time in the morning, so time check is 9 a.m. So I'm sure we can start the discussion of path analysis, the concepts and applications of path analysis. Then later on this afternoon, we can, I hope we can be able to discuss the application of path analysis using AMOS. Then tomorrow, we will discuss about confirmatory factor analysis. So if we talk about confirmatory factor analysis, it can be an opportunity for you to have a publication, research publication using confirmatory factor analysis. And then in the late in the morning, we can discuss the two approaches of structural equation modeling, namely the covariance-based ECM, and the other one is PLS ECM. In the afternoon tomorrow, we will have discussion about the covariance-based structural equation modeling using AMOS. Then in the third day, our focus would be on the second approach, which is partial least squares structural equation modeling using WARP PLS. Then in the afternoon of October 3, we will discuss about mediation and moderation analysis. Of course, if we talk about mediation and moderation analysis, there are approaches like the old approach, which is regression approach, but our approach for this webinar would be structural equation modeling approach. In particular, we will use WARP PLS. Then, of course, we will discuss about sample size issues in PLS SEM. Okay, so for the part one um, of our webinar, so we will go now to the path analysis. From path analysis to confirmatory factor analysis and structural equation modeling. So this is just an overview. It's something like showing to you the view of the of path analysis, confirmatory factor analysis, and structural equation modeling. So for the outline, let's start the discussion with the variables. So we all know that when we talk about variables, we have the observed variables, and we compare it with the latent variables, because structural equation modeling is utilizing the latent variable concept. Then we will differentiate the two terms in the reflective latent variable and formative latent variable. Then after that, we will discuss, or I'll show to you some slides about path analysis and structural equation modeling. Then we will compare covariance-based SEM versus PLS SEM. Then, of course, as mentioned earlier, we will be using AMOS and WAR PLS, but there are other software, free software, for example, R. Of course, we don't discuss about R. We don't discuss about Python. We don't discuss about Smart PLS. We focus only on AMOS and WAR PLS. So it's one at a time. Okay, so if we talk about observed variables, so sorry, I'm not sure why there is echo. I suggest the host of this webinar, mas maganda i-mute muna yung participants. So the participants are encouraged to key in their questions if they have questions. I will finish first this set of slide, this particular topic, part one. I will finish first the discussion. Then after the discussion, I will stop, or I will pause for a while for the possible questions from the participants. Then in the meantime, while I am talking, I encourage everyone to key in their questions in the chat box. Okay, so I am I think the audio is okay now. Okay, so for the observed variables, when we talk about observed variables, these are variables that can be observed directly by the respondents. And it is usually indicated in the survey questionnaire. So if you are utilizing a survey questionnaire, you can see some demographic profile such as age, sex, religious affiliation, marital status, and many more about demographic profile. And also, we observed that in questionnaire, there are Likert type items. Usually, the respondents are asked to indicate their level of perception per item. So all of these are called observed variables. So observed variables are common in research, um, the idea is that these variables can be measured directly by the respondents or by the researcher. Okay, so latent variables, on the other hand, these variables cannot be observed directly. So researchers utilize statements or indicators that can help in measuring the latent variable. So I mentioned earlier that the items in the questionnaire are observed. The Likert scale type items are also observed. But of course, there is a variable that are measured by this Likert type items. For example, teaching performance. Teaching performance cannot be observed, cannot be measured directly. We need items in order to measure teaching performance. So that's the reason why if we measure teaching performance, we need to develop an instrument that can measure teaching performance. So the teaching performance is a latent variable, and this latent variable can be measured using the items, using the statements or Likert type items. So the Likert type items are the observed, and teaching performance is the latent variable. So in the same manner, we have the work satisfaction, organizational climate, drunkenness. For example, if we measure drunkenness, um, the personality traits of persons, and student engagement, okay, critical thinking. Um, those are examples of latent variables, and those latent variables can be measured only if we have indicators or statements or items. And usually um, we can measure those items by using items, by using, for example, Likert scale type questions. And so that's it. That's about the difference between latent variable and observed variable. But of course, um, for example, teaching performance, a very simple example about its indicator or about its items. So the instructor creates online activities to increase students' interest. The instructor's online activities are aligned with the syllabus. These are the type of items that I am talking about. These items are called indicators of teaching performance. We cannot measure teaching performance without these items. Okay, so the statements that shall be provided to the respondents to indicate their perception are called indicators of teaching performance. So teaching performance is a latent variable, then these items, these indicators are observed variable. Okay. So another one, we have satisfaction, assuming that you stay in a hotel, you have hotel accommodation, for example, and um, based on experience, if we stay in a hotel, we usually there is a mini survey that shall be provided to us or shall be conducted, and of course sometimes we are asked to answer or to complete a mini survey asking us about the level of satisfaction. Okay, so for example, the item is, I feel comfortable in this hotel. I am happy to stay in this hotel. I recommend this hotel to others. These are indicators of satisfaction. So look at the two types of latent variable. So how do we measure satisfaction? So there are two ways on how to measure satisfaction. Look at the left side, the reflective latent variable. So that the researcher can be able to measure satisfaction, we need items such as I feel comfortable in this hotel, I am happy to stay in this hotel, I recommend this hotel to others. So obviously, the items are correlated. So correlated in the sense that if the person or if the customer is very satisfied on the first item, most likely they are also uh, highly satisfied on the next two items. So that is why we call it highly correlated indicators. If you are, if you feel that you are comfortable in staying in the hotel, then most likely you will be happy to stay in the hotel, and most likely you will recommend the hotel to others. Okay, so the direction of the arrow is from the latent variable, the oval, going to the item. So meaning to say, it is your level of satisfaction on the items depends on the overall level of satisfaction. Depends on your experience while you are staying in the hotel. So your perception, your level of satisfaction on every item depends on your overall level of satisfaction. So the latent variable, the LV, causes the indicators. So that's the reflective latent variable. So we all know that if we have that arrow, then we can be able to compute for the coefficients, the lambda 1, lambda 2, lambda 3. We can be able to estimate that if we standardize that lambda 1, lambda 2, lambda 3, that values are called factor loadings, or we call it indicator loadings. But technically, they are correlations between the latent variable and the items. So the higher the relationship between the latent variable, the oval, and the boxes, it means that the items are helping in measuring satisfaction. So it is different from our traditional approach that if you have items, all you have to do is just to get the average. So in this case, it is not average, but we can provide factor scores, not the average. For example, if we have 3 items, the traditional approach is to average all the 3 items, so that item 1 plus item 2 plus item 3, then the sum of that divided by 3. So the result of that is the overall score for satisfaction. But here, it is different. It is not about averaging the items. On the other hand, if you look at the formative latent variable, you can see that the direction of the arrows is different. For example, satisfaction now, the oval, the latent variable satisfaction is affected by the items. So it is something about regression. So satisfaction is the dependent variable, then the items affects each item affects the overall satisfaction. So the service room is well equipped, the personnel are friendly, the service is good. So obviously, we can do this formulation if the items are not correlated. Because if they are correlated, then we can encounter a multicollinearity issues. So multicollinearity problem is is not allowed in regression analysis, right? So in other words, in this formulation, the items served as the predictors of the latent variable satisfaction. So that is why the coefficients are W1, W2, and W3. So it is a formative latent variable. So for example, the service room is well equipped. So if the person, for example, is highly satisfied on that aspect about the service room, then it doesn't mean that that person is also satisfied on the next two items, because the next item is independent of the other. For example, second item is about personnel, friendliness of the personnel. So being friendly has nothing to do with the service room, right? So they are expected to be uncorrelated. Then the third is about the service. The service is good. So uh, um, this is not correlated with the personnel. Okay, so that's the two types of latent variable that we might encounter when we deal about structural equation modeling. Okay, so another one, we have in the left side, suppose we measure about drunkenness. Using reflective concept, we have the three items. These three items would go together, meaning to say if the level of dizziness is high, most likely the level of blurredness in speech, level of reaction would also be high, meaning to say they go in the same direction. That is why they are highly correlated. Okay, so more dizziness, the higher the speech blurred, the higher the level of reaction. So it means that they are they are highly correlated. So these three items is affected by the level of drunkenness of the person. Okay, so the higher the level of drunkenness, the higher also the scores in the boxes, the scores about dizziness, speech blurred, and slow reactions. On the other hand, if we formulate our meaning to say, if we measure drunkenness on another way, for example, if we measure based on the amount of beer, amount of wine, amount of liquor na ininom nila, so that's another way of measuring drunkenness. But if you look at if you analyze, for example, if the person will drink only the beer, kahit zero wine, zero amount of liquor, malalasing pa rin siya. So not necessarily na inumin mo yan lahat para malasing ang tao. So meaning to say the three, the beer, the wine, the liquor, are not correlated. So, but these three affects the drunkenness. One person might be drunk if he or she drinks beer, then zero wine, zero liquor. Then another person might drink wine, but do not or did not does not drink beer and liquor. Nalalasing pa rin. Okay. Okay, so this is the difference between reflective latent variable and formative latent variable. Okay, so path, when we talk about path analysis, it was devised by Sewell Wright in 1918. So actually scientist siya. So hindi siya social scientist, but biologist, something like that. So in path analysis, all variables are observed. During his time, during the time of Sewell Wright, the concept about about latent variable was not yet invented. This path analysis is an extension to regression analysis. So, di ba, ang regression analysis is also a path analysis. You have the dependent variable. Then this dependent variable is affected by the independent variables or the predictors. So that's a simple example of path analysis wherein we have only one dependent and many independent variables. So this path analysis can be utilized in confirming existing theory. So if you have a theory, then we can we can utilize the path analysis to confirm the theory. So this path analysis, in addition, can be utilized to test hypothesis. Okay, so I'll give you an example about testing hypothesis. This is the if you browse in Google Scholar, some publications that utilize structural equation modeling, the pattern of presenting the conceptual framework is similar to this. Every path corresponds to a hypothesis. For example, we have social economic status and quality of elementary school. If we draw a double-headed arrow, it means that the hypothesis is about correlation. So correlation between quality of elementary school and social economic status. So that's your H1, correlation between the two. Now, if it is, if one variable affects the other in the literature, if one variable affects the other, we can utilize the one-headed arrow. So, for example, quality of life or quality of elementary school affects scholastic achievement. So that would be that path corresponds to a hypothesis. So quality of life or quality of elementary school affects scholastic achievement. Then another hypothesis, social economic status affects scholastic achievement. So if you can see or if you browse some articles that utilize the structural equation modeling or path analysis, the hypothesis is the alternative, not the null. Kasi ang null, sabihin niya, quality of life, quality of elementary school does not affect scholastic achievement. But in the drawing, in the diagram, there is arrow. So if there is arrow indicating that the hypothesis is quality of elementary school affects scholastic achievement, or scholastic achievement depends on social economic status and quality of elementary school. Choice of secondary school depends on teacher recommendation, parents' preference, and school test score. So assuming that the graduating senior high school student, if they are asked about the choice of secondary school, their response might depend on the recommendation of the teacher, the preference of the parents, or the score in the entrance examination. Okay, so in other words, choice of secondary school is affected by teacher recommendation, parents' preference, and school test score. So there is arrow from one box to another, indicating that one variable affects the other, or one variable influence the other. Then there is H7, H8, H9. So of course, for every For every hypothesis, there is a corresponding statements in words, in addition to the diagram. So ganun ang uso ngayon sa mga publication. Nakalagay na ang nakalagay ang arrow, then there is label for the hypothesis. Then of course, as you can see, if you are good in regression analysis, or if you have experience of using regression analysis, if we consider H7, 8, and 9, that corresponds to one regression analysis. But of course, if you look at the left side, yung teacher recommendation, parents preference, and school test score, magiging dependent variable with respect to the scholastic achievement. So the idea here is that in path analysis, you have to formulate first your theory. So conceptual model is a temporary theory. Temporary model, we call it research model. It's a temporary research model. Temporary kasi napansin nyo, we build our conceptual model. We build our research model. Sometimes we call it conceptual framework, right? We build that based on existing studies, based on the literature. Then, of course, after that, thesis na or dissertation, so that would be our conceptual framework. So we further investigate that framework. The fact that we want to investigate further, it means that it is still temporary, not yet a we want to confirm if the interactions about the variables are really there. We want to check whether that model is really hold for a particular population under investigation. So in other words, when you write your dissertation or thesis, it means that we have a temporary model, and that temporary model might be wrong, might be acceptable, might be incorrect. So if it is incorrect, then we correct, we modify. So that's the goal of that's the work of path analysis. However, in path analysis, the variables are observed. So that is why the boxes are represented by, or the variables are represented by boxes, indicating that the variables are assumed observed during the time of civil right. Okay, so given that we have already the theory, temporary theory, or the framework, so above, the upper part, the diagram above is the result of the statistical investigation. The idea is that we have the data, we collect the data, then we fit statistically we fit this data with the model. So we have the data, then we have the if you can still remember our chi-square, the numerator of the chi-square is observed minus expected, right? Observed minus expected. The same concept here. We have the observed, the gathered data, then the expected, the observed covariance matrix minus the expected covariance matrix. We want that the two, the observed and expected, should be consistent, meaning to say the difference of that is should be minimum. So the difference between the observed and expected should be minimal, and that is that difference is reflected in the chi-square. So if the chi-square is small, the p-value of that is large. Okay, so we want that the p-value should be greater than 0.05. So that that's the rule of thumb in science, that if we use a level of significance of 5% or 0.05, so that the model and the data are considered consistent, we want that the p-value is 0.5 or higher, p-value of associated with the chi-square. Okay, so in this example, the model is inconsistent with the data, is statistically inconsistent because the p-value is less than 0.05. The chi-square is large, 410. So our goal is to look for, or we want to modify the model as much as possible. Our model should be acceptable. The p-value should be greater than 0.05 so that it is acceptable. Fortunately, because of the AMOS software, we can be able to modify the model by connecting some boxes. So it is possible that some boxes, if we connect the boxes, parang realistic siya. So you can proceed to connect kung may sense. Kung logical, if one box is to be connected to the other box, kung logical naman, kung may sense naman theoretically, then you can proceed to connect that boxes. But of course, if, for example, we found out that one box, if we connect the boxes and the p-value improves, then that's the time that we can be able to produce an acceptable model. So in path analysis, we are testing the entire model. Hindi pa muna yung hypothesis. The entire model is to be fitted with the data, or the data should be fitted with the model. Dapat yung data natin, the gathered data should be consistent with our model. Okay, so that's the basic concept of path analysis. We gather the data, then we fit our data with the model. If the model fit statistically, or if the data are consistent with our model, then we accept the model. However, based on my experience, I've been using path analysis and structural equation modeling since 2004, after my training in Singapore way back 2004. Nag-start na akong gumamit ng path analysis and structural equation modeling in 2004. Based on my experience, kapag mayroon kayong framework, hindi talaga siya mag-fit statistically. That is why we need to modify the model. And of course, when we modify the model, it should be guided by data and theory. So hindi lang pwede na based on data lang. So it should be guided by both data and theory. So kumbaga, theory and data driven. Both theory and data driven. Pwede natin yung gagamitin sabay-sabay. Okay, but the idea here is we can modify. We are allowed to modify as long as mayroong as long as ma-justify mo na yung one variable affects the other. Okay? So do not if we conduct path analysis, it doesn't mean na iraran mo lang yung software, then yun na. So you need to check first the consistency of the model and your data. So if your data is your gathered data are statistically consistent with your model, then you can proceed. But if your data are statistically inconsistent, then you can improve first your model. So, ibig sabihin, bago mo i-interpret yung mga hypothesis mo, kung i-reject or accept, dapat ay acceptable na yung model mo. Your model, and I'm talking of model, meaning to say research model or framework. Your data and model should be consistent. Kapag inconsistent, wala tayong karapatan na mag-decision kung i-reject o i-accept yung hypothesis mo. Okay? So, dapat bago tayo mag-decision about the hypothesis, dapat siguraduhin muna natin na yung ating data at saka yung model is statistically consistent. Fortunately, the software is user-friendly. The software can provide us guidance on which variables, which boxes should be connected. Yun ang advantage kung AMOS ang gagamitin natin, because the AMOS can provide us the we can do it easily. And aside from that, I suggest that when you teach AMOS, or when you teach structural equation modeling or path analysis, use AMOS because it's graphical. It can be easily understood. Okay. But kung advanced na yung students mo, advanced na yung students, whether graduate school students, advanced na, kaya na nilang interpret kahit walang diagram. So, okay naman kung gagamit ka ng R. R is free, so you can utilize R. Or you can utilize M+. Okay. But for beginners, so I always use AMOS for beginners. Okay. So steps in conducting path analysis. First is formulate the conceptual framework or research model. So that is why the path analysis is considered as a confirmatory analytical tool, because we always start from theory, research model. So we always start with the formulation of our framework, our research model, and the formulation of that research model should be based on theory and review of literature. Then after that, we gather the data. Then after the gathering of data, we fit our data with the research model. Then we accept the model if it is statistically consistent with the data. Then, of course, if inconsistent, if the result is inconsistent, then we revise the model or find alternative models that fit statistically with the data. Then after that, we can be able to interpret the results. So in other words, there are two major output. The first output is the theory itself. The theory, of course, is represented by our model as a whole. Then after the theory, we can be able to test the hypothesis. Kasi may possibility na yung mga path na nandyan ay nadagdagan. May possibility na ang mga path na nandyan ay nabawasan. Okay? So, yan yung path analysis. Okay? So, let's proceed to the structural equation modeling. So, the idea is that we have the path analysis. Then, we add this latent variable. The concept of latent variable is added in the, idagdag lang natin this latent variable in the model. So SEM integrates both the observed and latent variables in the model. So therefore, SEM is an extension of path analysis. So as mentioned earlier, path analysis is an extension of regression. Then structural equation modeling is an extension of path analysis. So the early development of structural equation modeling was due to the following scholars: Carl Juriskog in 1969, in 1973, Ward Kisling in 1972, David Wiley in 1973. So these are the scholars who developed the structural equation modeling. Then simula nung inimbento na nila yung structural equation modeling, up to now, nagkaroon na tayo ng mga highly sophisticated software like the AMOS, IBM SPSS AMOS. Okay, so the concept is like this. We have we start again with a theory. So assuming that in this example, I have satisfaction with physician service. So satisfaction with nursing service, satisfaction with waiting time, then the overall satisfaction. So this is a model about satisfaction of the patients in the hospital setting. Kasi napansin ko, even myself, I have an experience. I have before the pandemic, I had a yearly checkup in my with my doctor, with my family doctor. Kapag pumupunta ako sa clinic, kahit sa clinic lang yun, check-up lang, yearly check-up lang, maghihintay ka. So you have to wait with, maghihintay ka sa doktor mo. So mayroon namang upuan, aircon naman. So maghihintay ka dahil naunahan ka ng ibang mga pasyente. So there is really a satisfaction with waiting time. So there is a component about waiting time. Okay. So the waiting time, there is also satisfaction with nursing service. Kung, for example, in the setting of emergency room, for example, pagdating sa emergency room, mayroon tayong waiting time, mayroon tayong satisfaction with nursing service, satisfaction with physician service, then overall satisfaction. So the theory suggests that physician service affects satisfaction with waiting time, so that the higher the level of satisfaction with physician service, the higher also the level of satisfaction with waiting time. Yan yung H1. Then H2, the level of satisfaction with nursing service depends on the satisfaction with waiting service. Then satisfaction with nursing service affects the overall level of satisfaction. Each of that ovals has items or indicators. Kaya tinatawag natin yan ng latent variable. So in other words, if we compare path analysis and structural equation modeling, ang difference lang is that the way we measure the variables. Kasi kanina, box lang yon, indicating that the variables are assumed, observed. So usually, yun yung traditional approach natin na ina-average. Ina-assume natin na walang error when we measure the items. Dito sa structural equation modeling, all variables are latent. We need to develop a questionnaire muna. We see to it that for every oval, lahat ng ovals nandyan ay mayroon tayong very good items. When we say very good items, yung mga items na yun can help us in measuring the variables, can help us in measuring overall satisfaction, can help us in measuring satisfaction with waiting time. Those items should be useful in measuring those circles. Okay, so when we say useful, it refers to the validity and reliability. Sa structural equation modeling, mayroon tayong tinatawag na convergent validity, discriminant validity, then we have also reliability. So hindi lang siya reliability, but we are also concerned about the validity of the instrument. In particular, we call it construct validity. So the construct validity as well as the reliability shall be investigated first before we can be able to test the entire theory and hypothesis. So it's something like this. So if you look at the diagram, you can see that the variables are represented by the ovals. So these are the variables. Satisfaction with physician service. Okay. Then of course, these ovals can be measured, or these variables can be measured if we have items. The items are represented by boxes. Okay, for example, if we measure the overall satisfaction, we have two boxes. These boxes are labeled F3, F4, meaning to say these are the indicators of overall satisfaction. Yung nasa box, yan yung nakalagay doon sa questionnaire. Okay, so for example, satisfaction with waiting time, we have two items also. Okay, C1 and F1. These are the items that can be used to measure satisfaction with waiting time. Then if you look at also satisfaction with physician service, in the same manner, we have C5. Ito yung item that can help us in measuring physician satisfaction with physician. We have C4. We have also C3. Now notice that again, yung mga box dyan, nakalagay na box. Yung C3, C4, C5, B2, lahat na yan ay mga items doon sa questionnaire. So in other words, for this model, the researcher has 10 boxes. So meaning to say 10 boxes, the researcher has 10 items in the questionnaire, so that the researcher can be able to test this model. Mayroon siyang 10 items, Likert type item. Now, if that questionnaire shall be administered to the patients, there is error in measurement. Meaning to say, hindi tayo makakuha ng 100% na data, error-free. There should be an error in measurement. Kasi nga, yung ating item, if we administer that item to the patient, ano lang yan, perception, di ba? So, hindi yan siya error-free. Kaya mayroon tayong E1. So, this E1, yan yung tinatawag nating error in measurement. So, we have E1, E2, error in measurement yan. Meaning to say, for every item, there is a corresponding error. When we administer the questionnaire, there is error in that. Error, ang tawag natin sa error na yan is error in measurement. Measurement error. And that measurement error cannot be measured directly by the researcher. Kaya oval ang presentation. The ovals represent the error in measurement. Okay? So napansin mo na mayroong bawat item, bawat box, mayroon siyang corresponding error. So in other words, if we measure satisfaction with physician service, we need the items C3, C4, C5, and also we want to account the error in measurement. Okay? Hindi naman siya perfect dahil una yung the way you formulate your items plus yung other factors affecting their perception about the items. So mayroon talagang error in measurement. Okay, so ganon din sa satisfaction with waiting time. We have two items, C1 and F1. So we need this error in measurement or measurement error. So all measurement errors are ovals, indicating that the measurement errors are also latent variable. Okay? Latent variable. So sa traditional kasi na approach, kapag mayroon kang tatlong items about the satisfaction with physician service, i-average mo lang yung items. So sino nagsabi sa atin na yung average? Pag sinabi natin average, halimbawa item 1 plus item 2 plus item 3 divided by 3. So it means that the weight of that is 1/3. 1/3 of item 1 plus 1/3 of item 2 plus 1/3 of item 3. So who told us that the weight is 1/3? Equal weights ang assumption. So dito hindi. So aside from the data that we collect from the respondents, mayroong error in measurement and we account that error. We model that error. Kaya itong kung lalagyan ko ng i-encircle ko, ito ay isang latent variable. Yung buong satisfaction with physician service, we have the latent variable plus the observed variables na C3, C4, C5 plus the another latent variables that represent the error in measurement. Now, if you look at also the effect of physician service, satisfaction and physician service on the satisfaction with waiting time, napansin nyo na mayroon tayong tinatawag na prediction error. Di ba pinipredict natin yung satisfaction with waiting time? So when we predict, there is error in prediction. So ito naman yung E11. Okay? So yan naman ang error in prediction. So the error in prediction is, again, that's another latent variable. Okay? So napansin nyo, lahat ng dependent variable dyan ay mayroong error in prediction. For example, overall satisfaction. Overall satisfaction is another example of dependent variable. So mayroon siyang error in prediction. So E12. The same also with satisfaction with nursing service, mayroon tayong error in prediction. So mayroon tayong another oval affecting to nursing with satisfaction with nursing service. Another oval affecting overall satisfaction. Another oval affecting satisfaction with waiting time. But satisfaction with physician service, wala siyang error in prediction kasi hindi naman siya dependent variable. Okay? So that's how we formulate our model, our structural equation model. Okay, so of course, since the variables are latent variables, before we investigate the effect of one latent variable on the other, we make sure that the latent variable is valid and reliable. Okay, so in other words, there is measurement error to be assessed first before we can investigate the effect of one latent variable on the other. So in short, we always remember the saying that garbage in, garbage out. So kung ano ang psychometric properties ng inyong variable, ng inyong latent variable, kung bad, kung pangit, you cannot expect a valid findings in terms of effect of one variable on the other. So dapat siguraduhin muna natin na valid and reliable yung ating latent variables bago tayo mag-investigate ng effect of one variable on the other. And aside from that, the next to that, halimbawa, okay na yung validity and reliability of the four latent variables. Kung okay na, then we check the entire model. Yung data mo ba, yung gathered data mo ba is statistically consistent with your theory? So remember that your theory is represented by this framework, by this operational framework. Yung data mo ba is statistically consistent with that? If yes, then proceed to accept the model. It means that you confirm that the theory is really like that. However, for example, in this case, it is not acceptable because the p-value is less than 0.05, or the root, the other fit indices like the root mean square error approximation, yung RMECA, greater than 0.08, so it is not acceptable. Dahil hindi siya acceptable, we try to improve, we try to modify the model. The software can be able to produce, or can be able, has a capability to suggest an acceptable model like that. So sa theory, dito sa umpisa, wala kang line connecting physician service. This is just an example only. Wala kang line na nakakonect dyan, but you discovered during the statistical analysis, you discovered that dapat pala mayroong line, mayroong path from that, so that the chi-square will reduce. So look at the chi-square. If you look at the chi-square, the original chi-square, meaning to say based on your theory, 204. Pero when we follow the suggestion of the software na i-connect pala yan, may arrow pala yan dyan, may arrow pala dyan, then of course, lumiit ang chi-square. Okay? Lumiit ang chi-square, naging 65.503. Kanina is 204. So, biro mo, lumiit siya ng almost 4 times. Almost 4 times reduction in the value of chi-square. But the p-value is still less than 0.05. But the other fit indices like the RMECA, the GFI, the AGFI, CFI, and other fit indices na i-discuss naman natin yan later on, acceptable na sila. So indicating that our first attempt, our temporary model, ang temporary model natin yung nasa left side, na walang arrow pointing to the overall satisfaction. So, ibig sabihin wala ito. Yan. Okay. Ibig sabihin, hindi siya, misfit siya. Then, after our statistical investigation, we come up with a model with an acceptable fit, yung nasa right side. And that acceptable fit, ibig sabihin, the chi-square is smaller, relatively smaller as compared to the original. Then the other fit indices are statistically acceptable based on the rule of thumbs. Okay, so in short, it is about model testing. So both path analysis and structural equation modeling are model testing. So kung during your testing, kung acceptable ang fit, so you can accept the theory. However, if the model is not acceptable, then you can modify. But the modification should be guided by theory. Halimbawa, dapat i-check mo kung ang physician service ba talaga mayroong effect sa overall satisfaction. O yung waiting time ba talaga mayroong effect doon sa nursing service. Baka baliktad. Baka nursing service ang mayroong effect doon sa waiting time. Okay? So that's the structural equation modeling. So structural equation modeling, of course, the variables are latent variables. Pag sinabi nating path analysis, the variables are observed. But path analysis is an extension to regression analysis. So how do we present that in our paper? So obviously, yung ating original theory, original model natin ay hindi siya acceptable. Okay? So we accept the modified model, yung nasa right side, because that is yun yung acceptable model in terms of goodness of fit. But of course, the first ang first na problema sa mga students, lalo na ako, I've been in the consulting since 2004. Okay? When I said consulting, sa mga dissertation, thesis, sa mga company research, napansin ko sa academe, sa graduate school, mayroong conflict between the traditional professors. Yung mga traditional na professors that I am referring to are those who don't know about, no knowledge about structural equation modeling. Siyempre, ang thinking nila ay mag-focus lang tayo sa hypothesis testing. So we can solve that problem. Dahil yung hypothesis testing, we can still test. We can still test the hypothesis testing. Yung H1 up to H4 kanina, ito, H1, H2, H3, then H4. The only difference is that we can be able to add more path in the model. Like this, we have extra from physician service going to the overall satisfaction. That's an extra path. That extra path, meaning to say, yung path na yan, wala yan doon sa original mong framework. Dinagdag mo na lang yan because you discovered that that path is statistically significant. And that path, if you add that, yung model mo ay magiging acceptable. So, idagdag mo lang ito para walang conflict between your traditional reviewers, traditional panelists. So, para hindi kayo mag-aaway, i-retain mo yung hypothesis mo na 4 at dagdagan mo ng you add the significant path in the findings. Okay? And aside from that, yung model mo, of course, sabihin mo na hindi siya acceptable ang original model mo. So that is why you attempted to modify. And your modified model is presented. Yun yung i-present mo sa final section of your research. So mayroon kang final section. Kasi napansin ko based on experience sa mga academic institutions, ang mayroong framework. Yes, we are talking here of quantitative research, right? Mayroong framework. Usually, if they don't know about the structural equation modeling, ang gagamitin nila is regression analysis. Mayroon kang framework, then you tested the series of hypotheses. So sabihin na accept, reject, something like that. But the panelists, including the advisors, including the student, graduate student, forgot to go back to the framework. Kung after the rejection, after the acceptance of the hypothesis, ano na ang itsura ng ating theory? So nakalimutan na natin because the focus of our analysis is on the rejection and retention of the null hypothesis. Pati null hypothesis pinaglipatihan pa. Sa publication wala namang null hypothesis. Research hypothesis lang naman doon. So isa din yan. Isa din yan mayroong inconsistency between the academe and yung tinuturo natin sa graduate school na naka-box tayo, nakalagay doon ay null hypothesis. Ang estudyante niyan mahirapang mag-convert sa kanyang thesis, sa kanyang dissertation into a publishable paper. I don't know kung bakit mag-stick tayo sa null hypothesis na kapag sa publication sa mga ISI or Scopus Index journals, hindi naman null hypothesis ang required doon. Like this. So SPS, meaning to say satisfaction with physician service, affects satisfaction with waiting time. So it is a research hypothesis, not the null. Tapos lagyan mo dito H1 is supported. Okay? So H1 is supported. So hindi siya nakakalito dahil ang drawing mo, ang diagram mo is research hypothesis. Tapos ang presentation mo is null, the opposite of that. So para consistent, kung ano yung nasa diagram, yun din ang hypothesis mo dapat. Okay, so isang ano din yan, isang gap, meaning to say there is mismatch between our training in the graduate school and the actual publication. Meaning to say the format of the manuscript acceptable in the research publication ay hindi match doon sa training natin sa graduate school. Isa din yung dapat i-solve ninyo para magiging productive ang faculty. Biro mo, gagawa siya ng dissertation, ang kakapal ng kanyang dissertation. Tapos, kapag plano niyang i-publish ang kanyang paper, i-chop-chop niya yon, di ba? For example, yung first 5 hypotheses niya, isang article. So, malaking trabaho ang gagawin niya sa kanyang paper dahil ang kanyang dissertation napakalayo doon sa format ng Scopus Index Journal. So, nakakatamad. So kaya ang nangyayari hanggang dissertation lang, walang nangyayaring publication. So isa din 'yan. Then aside from that, itong problema natin na tinitest natin itong ating framework at nakalimutan na natin na ano na nga ba ang final model natin. So kasi we focus on the hypothesis testing. We forgot the main goal of the study is to generate a theory kung as much as possible kung mayroon kang ma-generate na theory. So your generated theory might be your contribution to your field of specialization. Kasi yung hypothesis mo nag-exist na yon. Nasa literature na yon. It's either you accept, or your hypothesis is supported or not. But how about the theory? What would be the new theory now? So mas maganda mayroon kang additional section in the manuscript, in the results section, showing the final model. Hindi lang yung inumpisahan natin sa framework, tapos pagdating sa findings, wala ka man lang bagong framework doon. Or kahit man lang isang section na sasabihin na ito na yung framework ko dahil ang tatlong hypothesis ko ay rejected. The three null hypothesis ay retain. So ganito na ang bago kong model. So walang ganon eh. So hanggang hypothesis lang. Okay. So yan yung sa structural equation modeling. We start with the model, then we test the model. Then if the model is acceptable, then we proceed. If the model is not acceptable, then we try to improve and look for alternative models. So it's something like this. Structural equation modeling essentially, yung SEM integrates both the path analysis and confirmatory factor analysis, or the measurement model. It integrates both the path analysis kasi yung from one oval to another, yun yung path. But before we connect, or before we believe that one oval affects the other, we make sure that the oval, the latent variable is valid and reliable. Kaya mayroon tayong tinatawag na measurement model. Okay? So if SEM is employed prior to the testing of the statistical consistency between data and research model, the measurement model should be assessed in terms of convergent validity, discriminant validity, and reliability. Garbage in, garbage out. That is the reason why before we test the effect of one variable on the other, we make sure that the latent variable is valid and reliable. Okay, so if we conduct SEM, we don't forget these things. First, we formulate our framework, or we call it research model, based on theories and review of literature. Then we gather the data. Okay, then if you use the if you use instrument meaning to say yung questionnaire, research questionnaire. Kung mayroon kang research questionnaire, then do not forget to assess the measurement model. So yan yung dito. Sorry. Don't forget to assess the measurement model. So this part here. Okay. Then of course after that you assess the goodness of fit of the research model. So this part, yan dapat i-assess mo. Before you assess the goodness of fit of the research model, make sure that the measurement model, the validity and reliability are within the acceptable ranges. Now, after the measurement model, after the assessment of the measurement model, proceed to assess the goodness of fit of the research model. So when we say assess the goodness of fit of the research model, it is exactly the testing of the data and the model, the consistency of your data and model. If the model fit statistics are acceptable, then proceed. However, kung hindi siya acceptable, try to revise the model or find alternative models that fit statistically with your data. Then kung okay na yung mga steps na yan, then that's the time that you can interpret the results. You will have two set of results. Results about the research model, whether the model is acceptable or not, whether the model, you modified something in the model. Then after that, you can decide to reject the hypothesis or not. Okay, so rejection of the hypothesis, of course, can be the decision whether to reject or accept the hypothesis shall be conducted after na mo malalaman na mayroon ka ng acceptable alternative models. Okay? So for the covariance based, dahil dalawa nga ang approach natin, the modeling approach, this covariance based is SEM. The model can be tested, confirmed, and or modified or improved. Yun yung covariance based. Covariance based SEM develops a theoretical covariance matrix based on the specified set of structural equations. The technique focuses on estimating a set of model parameters in such a way that the difference between the theoretical covariance matrix and the sample covariance matrix is minimized. Okay, so remember that you have this multiple variables. So the multiple variables, for example, the latent variable consists of several indicators. Say, for example, x1, x2, x3, x4, x5, or item 1, item 2, item 3, up to item 50, all of that. Yung item 1 up to item 50, you can form a covariance matrix of that. So kaya dito meron kang sample covariance matrix. Okay? The sample covariance matrix, of course, so mayroon din kayong tinatawag na theoretical covariance matrix. So yung theoretical covariance matrix, this is the covariance matrix based on the model that based on the framework. Parang ano yan siya? Parang sa chi-square, yung chi-square test of independence. Mayroon kang observed data minus expected, di ba? Expected. So yung expected corresponds dito sa theoretical covariance matrix. Then isa-subtract yan, the result of that is minimum. So basically, kung pag-uusapan natin ang calculus, it is something about finding the parameters of the model, so that the difference between the sample covariance matrix and the theoretical matrix is minimum. So find the parameters, for example, path coefficients. Find the coefficients, find the path coefficients such that the difference between the sample and the theoretical covariance matrices is minimum. So it is calculus, basically. So application of calculus, maxima, minima. But we don't worry about the calculus because the formulas are already integrated in the software. Pipindot na lang tayo ng software. Okay? So the PLS naman, on the other hand, has a different approach. Okay? So for example, I have now 3 variables. So we have satisfaction, first variable. So satisfaction consists of 4 items, kaya may nakalagay dyan na 4i. Okay. Then we have loyalty also. Loyalty is a reflective latent variable with 6 items. Okay. Then of course, another variable, we have trust. Okay? Trust consists of 4 items, kaya may nakalagay na 4I. So the goal of PLS-SEM is to find the path coefficients. So yung path coefficients marami. So meron tayong path coefficient from satisfaction to loyalty, path coefficient from trust to loyalty, path coefficient from satisfaction to trust. So find these path coefficients such that the R squares are maximum. So when we say R squares, these are the values under the oval. This is the proportion of variance in the loyalty that is explained by the by trust and satisfaction. So meaning to say the variability of loyalty is 63%. 63% of the variability of loyalty is explained by satisfaction and trust. 49% of the variability of trust is explained by satisfaction. Okay, so the goal is to maximize the R squared. We look for the beta so that the R squared are maximum. So it is still a calculus problem, application of maxima minima. So, di ba, calculus, ano natin, we find the derivative, first derivative. So, everything about, but in this case, it is matrix calculus. Kasi multiple variables ito. Okay? We have two different approaches. The PLS-SEM maximizes the R squared, whereas the covariance-based SEM is minimizing the difference between data and the theory. Consistency of the theory ang tinitingnan natin dito. We want to find a model such that the data, the sample covariance matrix, and the theory are consistent. So they are consistent if the difference between sample matrix and theoretical covariance matrix is minimum. So the approaches are different. So kaya itong covariance-based SEM, ginagamit ito for confirmatory or theory testing. There is already existing model, and our goal is just to test or confirm the model. But of course, we can still modify if we want. Whereas dito sa PLS-SEM, since it is maximization of the R squared, it can be utilized in theory development. Okay, so theory development or prediction. So we can utilize this in kasi ito ay maximizing the value of R squared. Okay, so if we talk about covariance-based SEM software, we have the AMOS. So ang AMOS, the input, we literally draw the diagram. Later on, we will have this afternoon, we will have that. Talagang i-drawing natin yung diagram. Then, of course, we can draw a colorful diagram. Then, if we click the estimate, the software will generate the text output. So meaning to say, my tables plus colorful diagram with coefficients. The opposite is the IMPLUS. Kasi yung IMPLUS, ang input natin ay there are short codes or scripts. Then the output ay text output, then black and white diagram with coefficients. So ang input lang natin sa IMPLUS ay code lang. Kumbaga command. Then the software will generate the diagram as well as the text output. Parang SPSS siya, pero plus a diagram. Okay? The R software, the Labaan package for those who are good in R, of course, as usual, ang input natin dyan ay script. Then, ang text output, ang output natin ay yung text output only. Okay? When it comes to the PLS SEM, maraming software. Mayroong R, mayroong WAR PLS 7, mayroong Smart PLS. So, sa Smart PLS, yung diagram shall be drawn by the users. Colorful diagram can be drawn. The outputs, of course, include the colorful diagram with coefficient. The WAR PLS, yun yung favorite ko sa lahat dahil ang trial version niya ay 3 months. It can handle non-linear relationships. Kasi yung Smart PLS, linear relationships lang yan. Sa WAR PLS, it can handle non-linear structural equation modeling. So we draw the diagram, meaning to say we always draw the diagram as our input. Then the output of that WAR PLS, text outputs, black and white diagram with coefficients. Okay, so this is an example of the output of a Smart PLS. Okay, so yung green na nandyan, yan yung major variables, yung green. Okay, so ibig sabihin, we are interested of accounting competency, financial literacy, all of this green are the major variables of the study. So napansin nyo na yung green, mayroon siyang mga blue. So yung blue na yan, yan yung mga subdimensions. Di ba napansin nyo kung ang isang instrument, minsan mayroong mga subdimensions. Okay? Subscales. For example, teaching performance. Sa teaching performance, bago ka magkaroon ng teaching performance, mayroon ka pang i-measure ng mga mastery of the subject matter. Di ba? Sa amin, 4 na dimensions ang i-measure bago kami maka-come up ng overall. Teaching performance can be measured using 4 domains. The planning and preparation, classroom environment, instruction, and professional responsibility. So yung 4 na yon, yun yung blue. Tapos yung green, yan yung teaching performance. Tapos yung yellow box, yan yung items na nasa questionnaire. Okay? So in short, the major variables of the study are the green ovals. Then yung mga blue, yan yung representation ng mga dimensions. Then for every dimension, there are corresponding items, the yellow boxes. Okay? So, napansin nyo yung yellow boxes nakakonect doon sa blue. Okay? Nakakonect sa blue at mayroong corresponding factor loadings. Okay? Then, of course, yung blue, the blue ovals nakakonect din sa major variables. Okay. So we can simplify that. Sa Smart PLS, pwede natin i-hide yung mga yellow para ang makikita mo lang yung mga subdimensions. So meaning to say, for example, accounting competency, this oval, we can measure accounting competency if we have available AS, AK, and AV as dimensions of accounting competency. Then AS, AK, at saka AB, mayroon silang corresponding items in the questionnaire. Pero we hide para lang magiging simple. You have the option, pwede mo, ang ipakita mo lang ay yung green lang. Wala na yung blue, wala na yung yellow. Yung green lang. You have the options. That's smart PLS. Now, if we use the WAR PLS, ang approach naman nila ay iba. For example, satisfaction, this is the major variable. It consists of 4 items, reflective. So hinahide niya yung mga items. Loyalty consists of 6 items. Okay. Then of course, the trust consists of 4 items. Affective commitment consists of 3 items. Then relationship appeal consists of 1 item only. Then of course, you can see the effects of one oval to the other, represented by one headed arrow. Now, if your model consists of moderators, so for example, in this case, ang moderator natin ay IP. The moderator IP is connected to the path, so indicating that IP is the moderator of that model. Yan yung sample output ng WARP PLS. Okay, so I am done with the first part. I hope you were able to understand the concepts about path analysis, from path analysis to latent variable to structural equation modeling. Then there are 2 approaches of structural equation modeling. Okay, so before we proceed to the second part, let us have first the Q&A, questions and answers, just in case you have questions.
Yes, sir. Meron po tayo sa chat box po. Basahin ko lang po yung first question. Ayun po. From Sir Lawrence Osona po. Do you encounter measuring the performance or satisfaction using ratio or interval type, not a Likert scale? How do you deal with it?
Okay, there's no problem if the variable satisfaction is already a ratio or interval type, not a Likert scale. No problem. So you can handle it, assuming na ano siya, assuming na observed variable siya, then you can apply the path analysis. But of course, just in case yung mga variables mo ay mixed of interval or ratio, in short, continuous, tapos ang ibang mga variables ay Likert scale type, you can still utilize the structural equation modeling. Kasi ang structural equation modeling, mixed yan siya of observed and latent variables.
Okay po. Another question po from Sir Osona. In modifying the model, we will use trial and error method until you satisfy p-value must be greater than 0.05. Therefore, we can get more model with different paths. How can we select the best model among them?
Okay.
We need to show its UMVUE. Kung tama po yung basa.
Okay, so that's a very good question. So it is trial and error, but because the software is user friendly, the software can suggest a path. Ibig sabihin, the software has the capability to suggest us users on which variable to be connected so that the chi-square will decrease. So ganon po ang ano dito. Ibig sabihin, as a user or as an analyst, ang goal mo is to look for, tama po yun, trial and error, look for a possible variables na i-connect mo, look for possible ovals na i-connect mo so that the chi-square will reduce. And until na magiging greater than 0.05 yung p-value mo. Assuming that you have plenty of versions or more than one versions of model. Halimbawa, model alternative model 1, alternative model 2, alternative model 3, tatlo. lahat na yan ay acceptable ang P. Acceptable ang P-value. So which model should be recommended? So alin dito ang i-recommend mo sa ano mo sa meaning to say in your term, which is the best model? So yun yung term, that's the correct term. Out of the three alternatives, which one is the best? Okay, so you can utilize the Bayesian information criterion or the Akaike information criterion. So pwede rin siguro, pero sa software natin wala yung VUE. But the software has this Akaike information criterion, the AIC, and the other one is the Bayesian information criterion, or BIC. So the smaller the value of EIC and BIC, the better the model. So there's no problem when it comes to finding the best model kasi may mga fit indices naman tayo.
Sir, another question po from Sir Osona again. Are all hypotheses two-tailed tests or can we also use a one-tailed test?
Pwede naman ang one-tailed, pero ang default of the software is two-tailed.
And then, how do we measure the measurement error?
So of course, the measurement error, mayroon naman tayong tinatawag na estimation method. It is already embedded in the software. So for example, the default of the software is maximum likelihood estimation. So it is part of the parang regression analysis din, di ba? Regression analysis, mayroon tayong error term. There is a procedure on how to estimate the error term. So the measurement error.
And
Basta
then,
ilagay mo lang doon sa equation mo. 'Di ba yung diagram natin kanina can be converted into mathematical equations. 'Di ba? So mayroong nilagyan lang na siya ng extra term na error term at the item level. Yun lang po ang improvement from regression approach to structural equation modeling approach. Kasi yung error term ay kinalimutan na. Hindi talaga kasama ang error term sa estimation method yung doon sa regression approach. We assume na walang error yung halimbawa yung mga independent variables mo, yung dependent variables, you assume na walang error in measurement. But in structural equation modeling, nandoon talaga yung error terms. And if the question is how do we measure the measurement error, so it is part of the model. Parang naglagay ka ng error term at the item level. Whereas doon sa regression analysis, naglagay ka ng error term doon sa model level. Di ba? Halimbawa, dependent variable y equals bo plus b1 x1 plus b2 x2 plus error term. Di ba? May error term. So, yung error term na yon ay nasa prediction model lang yon. Error in prediction yon. Error in predicting y. Wala kang error doon sa item level. Whereas dito sa structural equation modeling, talagang dinagdag mo yung measurement error. Then, of course, translate that into mathematical equations. Yung diagram mo, i-convert mo into mathematical equation, then estimate. You can utilize the maximum likelihood estimation if the assumptions are possible.
Sir, meron pa po. Actually, ang daming Thank you, Sir Osona. No? We have fifth item. Why do we always use chi-square only? It is used to determine if the given data are independent or dependent. Can we use other distribution pre-tests to avoid giving the hypothesis? Can we also see the other test rather than chi-square?
Yung kanina, that is the statistical test of significance. Kasi yung approach ng covariance-based SEM is that data, the covariance matrix, sample covariance matrix minus the theoretical covariance matrix, the difference of that should be minimum. Kaya chi-square yan. Parang observed minus expected. Pero, of course, mayroong mga fit indices na babanggitin natin mamaya, just we will discuss later on, kagaya ng root mean square error approximation, goodness of fit index, marami, more than a dozen of fit indices, just in case hindi natin ma-achieve yung p-value ng chi-square.
Okay po. We also have a question from Ma'am Aprilyn Calvario. Sir, if we are using Likert scale in measuring the latent variables, is it okay not to have the same number of items for each subdomain or indicator?
Okay lang naman po. So that's measurement issues. So sa atin kasing sa science kasi mayroon tayong tinatawag na for example PhD in measurement and evaluation. So sa kanilang field yun, they are concerned about the number of items per variable or per latent or per dimension. So sila yung nag-aaral about it. Pero sa atin na level, allowed naman yung uneven number of items per dimension. So idagdag ko lang kanina sa question ni Sir Lawrence Osona regarding the distribution free test. Yung covariance based SEM is parametric test, meaning to say based on the distribution. That is why one of the test is chi-square test. So in case kung ayaw mo ng distribution, ayaw mo ng parametric approach, we can utilize the non-parametric approach, which is the PLS-SEM. So marami naman tayong options, kaya dalawa ang topic natin, covariance-based SEM, and the other one is a PLS-SEM. The PLS-SEM is the non-parametric counterpart of the covariance-based SEM, just in case you don't like the distribution assumptions.
Sir, from Ma'am Crisilda Bragas, is SEM-PLS ideal for comparative studies?
Comparative, what do you mean comparative? Kagaya ng t-test, ANOVA. Dito sa atin sa structural equation modeling, we can still do comparison. For example, if we have multiple groups, we can do multiple group SEM. For example, mayroon kayong model. Ang first, yung model mo ay mayroon kang 3 groups dahil mayroon kang engineering respondents, mayroon kang nursing respondents, mayroon kang education na respondents. Meaning to say you have 3 groups of respondents. Yung model mo ba will behave same behavior across groups? So meaning to say we can do a comparison in terms of path. For example, X affects Y. Is there a difference in the effect of X on Y across subgroups? So we can still do comparison. We call it multiple group comparison in structural equation.
Ay, bali po nag-follow up po si Ma'am Bragas. Ang tinutukoy niya po ay, for example, comparative study of organizational culture of higher educational institutions.
Pwede po kung gusto mong ano, pero ang i-compare mo dito mo yung model. When we say model, ang ibig sabihin yung path. Pero kung ang i-compare mo ay for example, mayroon tayong variables na organizational culture, organizational climate, for example, yun ang mga variables mo. But ang i-compare mo ay yung ang variables across groups. So, ANOVA lang yung gagamitin mo dyan. Pero kung ang i-compare mo ay yung effect of one variable on the other. So, ibig sabihin, pwede na siya na multiple structural equation modeling. Multiple group SEM.
Then another from Sir Ernesto Camino. Can we do principal component analysis first to arrive at a factor structure that we will use in SEM?
Okay. So actually, dalawa naman ang ano natin. If we talk about instrument development, we have two steps. For example, yung first study mo, gagawa ka ng instrument, magkanda ka ng exploratory factor analysis. Diba? In other words, your goal is to discover the possible factor structure of your variable. For example, yung organizational culture as a whole. Mayroon kang 50 items. You conduct a exploratory factor analysis. Then you come up with 5 factors. So in other words, yung culture na yan as a variable consists of 4 dimensions or 4 factors. Publish mo yan. So ibig sabihin it's instrument development. You are developing questionnaire that can measure organizational culture. And that organizational culture, based on your analysis, can measure 4 domains or 4 dimensions. So, ibig sabihin, kung ma-publish mo yan, you are developing a theory. Your theory states that organizational culture consists of 4 factors. So, may theory ka na. Ngayon, yung theory mo na yan, i-confirm mo yan. So, you will conduct confirmatory factor analysis. So it's another study 2. So study 1 is exploratory factor analysis. Your contribution to that is development of a new theory about organizational culture. Then study 2 is confirmation of your theory. So study 1 and study 2, you need to use different samples. Pwede naman mag-conduct ka kung gusto mo, but of course based on theory muna. Kasi ang gagamitin mong variables kapag mag-structural equation modeling ka na, nag-exist na yung mga variables mo. Kung gagamit ka ng covariance-based SEM. Pero kung i-develop mo pa lang yung theory, pwede kang yun nga, exploratory factor analysis. Then mag-confirmatory ka. Then yung bago mong ginawang organizational culture, i-correlate mo sa ibang mga variables. Titingnan mo kung mayroon ka bang mabuong structural equation modeling. That would be another study 3 na. I hope I answered the question.
Another po from Sir Osona po ulit. Can we use SEM for multivariate data?
Of course po, yung structural equation modeling is one of the multivariate models. So, multivariate data talaga yan.
Ay sir, at may ito po questions po galing naman sa akin. na medyo niluwa lang po ako ng Zoom kanina, kaya
Sige po.
baka po na-miss eh. When you say correlation, the lambdas, are you pertaining to, ito po ba yung Pearson, Spearman, Kendall, or baka iba pa po?
Dahil yan ay standardized, that corresponds to the Pearson R. Depende sa depende sa ating software, kasi may software na gumagamit ng Pearson R at mayroong gumagamit ng hindi Pearson R.
Okay.
Depende sa software. For example, yung Amos, ang ginagamit niyan ay Pearson R, pero sa IMPLAS maraming versions of correlation coefficients ang ginagamit doon.
Okay po. So sir, hindi po strict na may linear assumption na may ganun po?
Yes, sa Amos, ina-assume niya na linear ang relationship. Whereas sa WAR-PLS, pag titingnan mo yung website ng WAR-PLS, the WAR-PLS is designed for non-linear SEM. Pero partial least squares approach. Nakita nyo naman yung difference between the two approaches. Pag PLS SEM, it's maximizing the R squared. Pero pag covariance-based SEM, it is minimizing the difference between the observed and the observed covariance matrix and the theoretical covariance matrix.
Okay po, sir. And then, sir, kanina po, pag dun po sa mga graph or dun sa model natin, yung connection po sa pagitan ng dalawang nung dalawang rectangle or nung oval po, ito po ay nagre-represent ng positive correlation po. Tama po ba ako ng... Okay po. So pag sinabi
Yes,
niyo pong may relation, that pertains to positive correlation po.
Yes po.
Okay po, sir. Thank you po.
Actually, sa mga research, empirical research, of course, empirical ang pinag-usapan natin dito. Based on the literature, kung halimbawa lahat ng review mo, lahat ng existing studies, for example, X and Y, if the correlation is negative, so nilalagay mo na as sa hypothesis mo, H1 negative. So meaning to say, the researcher has already the idea that the relationship between the two is negative. So ang coefficient niyan ay negative. Pero kung mayroon kasing studies na nag-contradict, for example, 10 articles, sabi X and Y, ang correlation is negative. Pero another 20 researchers published articles, positive naman ang relationship. So, nasa sayo na yon kung ilalagay mo yung sign doon sa diagram, kung ang hypothesis na yan ay negative ba o positive.
Okay po.
So pag sinabi, sir, ano ko lang kung if I understood your question correctly. For example, X and Y, naka-connect yung double-headed arrow. So indicating that your goal is to test the correlation between X and Y. Pero hindi ibig sabihin na positive na yon, or depende sa result. It can be a positive or it can be a negative.
Pero sir, pagdating sa model, pag naiwan yung arrow, ibig sabihin po nun positive na? Or hindi
naiwan yung arrow?
Opo. Kasi
ibig
po di ba
significant?
Opo. Okay.
Yeah, significant.
Gets ko na, sir. Okay po.
Yes.
Sir, last question po.
Sige, sir.
Sa akin po. Kasi sir, ang napapansin ko po sa tradisyon natin sa paggawa po ng conceptual framework, di ba po may research paradigm po tayo doon?
Yes, sir.
And then there are these researchers, sinasabi nila mali daw po yung paggamit ng IPO, the Input Process Output Model. Ngayon, does it mean yung ito po bang dinidiscuss nyo sa amin, yung po ba ang dapat nakapwesto na research paradigm sa conceptual framework po? Or it is just another treatment?
Yung IPO, possible naman na nangyayari talaga yan eh. yung input, process, output. For example, mayroon talagang mayroon ka namang mga variables na dumadaan sa sa input, process, output. For example lang sa input, yung high school grades. High school grades, tapos pagdating sa university, 'di ba, marami ng diyan, may mga grades na siya ng may grades na siya ng mga subjects. Pati level of satisfaction niya sa within the universities nandyan. Di ba bilong yan sa process. Tapos sa output, yung board exam results. Di ba ang nangyayari, input, process, output. Pero huwag mo na lang ilagay yon dahil hindi yung ibang panelist ayaw nila yon. Pero ang actual na situation ay input, process, output talaga. Ang ilagay mo na lang doon sa model mo yung high school grades, college grades, at saka yung board exam results. So nakabuo ka na ng structural equation model.
Okay po, sir. So far, sir, wala na pong tanong sa chat box po.
Okay. So, time check, almost 11. So ano ba ang, ako ba ang mag-decide? Baka kasi na na kayo. Ako okay pa ako. Kasi we still have 1 hour. It's up to you. I can proceed. Then, for example, kung aabot tayo ng 12 o'clock, so pwede naman tayo babalik ng 1:30. Or we can dismiss early, then we will go back at 1 o'clock. It's up to you.
So sir, hindi na po tayo mag-health break na 10 minutes. Diretso na po tayo.
Sige.
Or lunch break po.
Mag-health break tayo. Kung gusto niyo.
10 minutes po, sir.
Yes, 10 minutes.
Opo.
We are break. Okay.
Thank you po. Okay, so dear participants, we can have our health break. No? Balik po tayo around 11:10. Thank you po.
The Polytechnic University of the Philippines has issued the Executive Order Number 26, Series of 2020, Guidelines in REAP3, Research Activities, Production, Presentation, and Publication or Patent for regular faculty members. This order is being issued to prescribe the guidelines on research production, presentation, and publication or patent for regular faculty members in any academic program level of all academic units of the university. This intends to sustain the significant achievements of the past PUP administrations in strengthening the research culture in the university and to meet the quality standards for a higher education institution set by CHED and other national and international regulating and accrediting institutions. The burgeoning research potentials of faculty members, compliance with institutional, national, and international guidelines and standards will lead to a stronger and internationally recognized Polytechnic University of the Philippines. General provisions. Each regular faculty member shall participate and complete all research activities every R&D cycle. Research activities may be a sole or a collaborative effort, funded by the university or an external agency, and community-based action research, basic research or applied research. For collaborative research publication, a research article from a thesis or dissertation is allowed provided that an authorized co-authorship agreement with the student researcher is entered into stipulating that the regular faculty member is the corresponding author. For each research work leading to invention, the utility model, industrial design or patent must be applied at the Intellectual Property Management Office. For every internal or external research collaboration, all regular faculty members must observe the prescribed minimum role or involvement and the university guidelines on research ethics. In case that the research work is not completed within the allowable period of 1 year for internally funded research and 3 years for externally funded research, the researchers may extend the project subject to the approval of the university of the funding agency. With the approved extension, the researchers are still considered compliant with the R&D cycle. Otherwise, the research collaboration is considered terminated. Researcher must mention in all their research works the name of the university as author's affiliation. Responsibilities. On research production, a regular faculty member whose rank is associate professor must participate in a research work, at least, as an assistant team leader or co-lead researcher in every R&D cycle. A regular faculty member whose rank is full college or university professor must lead a research work or conduct a research work as a sole researcher in every R&D cycle. On research paper presentation, a regular faculty member whose rank is associate professor must present research results in any national or international research conference every R&D cycle. In the case of collaboration, one research presentation shall be credited to the entire team. A regular faculty member whose rank is full college or university professor must present research results in any international conference every R&D cycle. In the case of collaborative effort, one research presentation shall be credited to the entire team. On research publication, a regular faculty member whose rank is associate professor must publish research results as co-author or lead author in every R&D cycle in any international, national, or local referee journal with an established reputation. A regular faculty member whose rank is full college or university professor must publish research results as lead author or sole author in every R&D cycle in any research journal indexed by Scopus, Web of Science, Excellence in Research for Australia, ASEAN Citation Index and are recognized by CHED or Philippine Association of State Universities and Colleges. A granted certification of invention from Intellectual Property Office of the Philippines is considered an alternative in lieu of publication, which will be credited for 1 R&D cycle in the case of utility model, and 2 R&D cycles in the case of patent. A faculty designee whose rank is at least associate professor must participate in all research activities in a limited capacity at least as a member of the research team and as co-author of a research article. Working hours. The working hours of the regular faculty members and faculty designees are herein set in accordance with Civil Service Commission Memorandum Circular No. 19, 2005, SUC Merit System, Chapter 5 Working Hours, to wit, faculty members, except those covered by special laws, shall render not less than 8 hours of work a day for 5 days a week, or a total of 40 hours a week exclusive of time for lunch. The 40 hours a week may include time for teaching, student consultation, research and extension work, and other activities relevant to teaching, like preparation of lessons, checking of papers, etc., which shall be left to the discretion of the governing board of the SUC. Head of the department in the SUC may allow flexible working hours for his or her faculty members, so they can perform their fourfold functions of instruction, consultation, research, and extension services, provided that the prescribed 40 hours of work per week shall strictly be implemented. All regular faculty members in the PUP system shall abide by the following regular working hours scheme. All faculty designees across colleges, branches, and campuses in the university shall abide by the following working hours scheme. A report on official time must be observed by all regular faculty members and faculty designees. Part-time and temporary teaching loads must be considered as an overtime actual service work and must be outside of the 40 hours of work per week. Deliverables. All regular faculty members and faculty designees must submit the following proofs of compliance. Submission of proof of compliance must be made 3 days before the holiday break of every calendar year to the following offices: Sanctions. A regular faculty member or faculty designee who fails to comply with these guidelines for at least one R&D cycle shall be ineligible for the following: all financial rewards and incentives consistent with other existing relevant university rules and regulations until the faculty member has complied with Section 3 of this guidelines. 6 units of part-time teaching load in the semester following the R&D cycle of non-compliance until the faculty member has complied with Section 3 of this guidelines. 12 units of part-time teaching load in the semester following the second of 2 consecutive R&D cycles of non-compliance until the faculty member has complied with Section 3 of this guidelines. And teaching load in any graduate program in the university system in the semester following the R&D cycle of non-compliance until the faculty member has complied with Section 3 of this guidelines. The sanctions shall become effective in 2022 at the end of the first cycle. For more information, visit www.bup.edu.ph/research/RMO or contact your respective faculty researcher.
Good morning. Okay, so as we resume the second part of the morning session, again, we have Dr. Johnny Amora.
Okay, so we proceed to the path analysis using AMOS. So of course, our plan is to have a live hands-on regarding path analysis using AMOS. We will do that this afternoon, of course. For now, let us have this short discussion about correlational research design, because path analysis is one of the techniques about correlational research design. Then, of course, we will see some model fit indices just in case the chi-square is not possible, so we can use other statistical test available. We call it model fit indices. Okay, so from the book of Creswell and Creswell 2018, we have correlational research as part of the non-experimental quantitative research. So the other one is the causal comparative research. So when we say causal comparative research, that includes the statistical test such as the t-test, the ANOVA, and for the correlational research, there are plenty of statistical tests. When we talk about correlational research, depends on the level of measurement of our our data. So according to Creswell, correlational research design, the investigators use the correlational statistics to describe and measure the degree or association between two or more variables or set of scores. So for example, if you have two variables, COVID-19 literacy and COVID-19 anxiety, the goal of the research is to investigate if there is relationship between the two variables. So our research question is there a relationship between COVID-19 literacy and COVID-19 anxiety? Then scientific approach is we test the research hypothesis. There is a relationship between COVID-19 literacy and COVID-19 anxiety. And of course, if we utilize the the traditional approach na talagang ilalagay natin yung null hypothesis, so it's up to you. You can still use the null hypothesis. There is no relationship between the two variables. Okay, so if we talk about statistical techniques for correlational research, we have this bivariate. So when we say bivariate, so it refers to the two variables at a time. So for example, the variable is X and Y. So we can investigate the relationship between the two. For example, COVID-19 anxiety, we want to correlate it with the COVID-19 literacy. So X1 versus X2, two variables at a time, of course. One of that is Pearson correlation. Sometimes we are confronted with data that are multivariate in nature. For example, you have two sets of variables. First, we have X1, X2, X3, X4. Then the other one, we have Z1, Z2, and so on and so forth. An example of that is pre-employment exam. So the pre-employment examination consists of several dimensions, several factors. So factor 1, factor 2, 3, and 4. Meaning to say there are subtests. There are several subtests in that pre-employment examination. Then you want to correlate that scores with the work performance. Talking of work performance, there are also several dimensions. We call that dimension 1, dimension 2, 3, and 4. So if we want to investigate if there is correlation between these two sets of variables, so of course, one example of that is canonical correlation. Then third bullet, there is another relationships that we want to test. We have one DB and one dependent variable and many independent variables. So we can utilize the regression analysis for this. Depending on the type of regression analysis, because if the dependent variable is continuous, then we can utilize the linear regression or the non-linear regression, such as the logistic regression. If the dependent variable is dichotomous, but logistic binary logistic regression. If the dependent variable is nominal with more than two categories, then we can utilize the polytomous logistic regression. Then there is also ordinal logistic regression. There is Poisson logistic regression. Now the fourth bullet, we have many dependent variables with many IVs, many independent variables. So that's the time that we can utilize the path analysis or the structural equation modeling. Path analysis if the variables are observed, then structural equation modeling if the variables are latent or unobserved variables. So there are plenty of statistical tests. I mentioned earlier about the logistic regression, multinomial, logistic regression, binary. We can also use the discriminant analysis, conjoint analysis. All of these are multivariate statistical techniques. And of course, if we talk about multivariate data as asked earlier by a professor, so structural equation modeling, path analysis are part of that multivariate statistical techniques. So in fact, we have the canonical correlation, we have the I forgot to indicate here the factor analysis. We have the cluster analysis, Poisson regression, ordinal regression. So the Poisson regression is useful if the dependent variable is count. So for example, number of positive cases at the barangay level, and you have plenty of barangays nationwide. So you can have that Poisson regression to model the number of cases at the barangay level. Okay, so there are plenty. So I created this flowchart B for my students, beginners, the master's level. It's very easy to use. I call it flowchart B, statistical techniques for testing relationship between two variables. It's very easy to utilize because I start with a variable one. So variable one, of course, it can be continuous, nominal, dichotomous, or ordinal. Then the variable two can still be continuous, nominal, or ordinal. So if, for example, the first variable is nominal, then the researcher will proceed to this path. Then if the second variable is continuous, so the researcher can proceed to this path. Then he can utilize this statistical test, for example, Kramer's B. However, the researcher would or should collapse first the continuous variable so that he or she can utilize the Kramer's B. Mayroon namang note dito sa baba, if variable 2 is collapsed into categories. Okay, so just in case the first variable is nominal, the second variable also is nominal or ordinal, so the researcher can utilize the Kramer's B coefficient. So in case the first variable is continuous and the second variable also is continuous, then he or she can utilize Pearson R. So these are just guide on how to determine or how to choose the appropriate statistical test in case the goal of the research is to test if one variable is correlated with the other. So this is also another flow chart. I call it flow chart C. This is this is about regression types, because we all know that we have linear, we have binary logistic regression, we have Poisson regression, we have negative binomial regression, multinomial regression, ordinal regression. There are other types, but I only put this 6 different types in my class. So for example, if it is if the dependent variable is continuous, so dito siya mag-proceed. And of course, yung ating independent variables, predictor variables, can be one or more. But as long as the dependent variable is continuous, so we can utilize the linear regression. Then, of course, if the dependent variable is dichotomous, so ito yon, dichotomous. So the researcher can utilize the binary logistic regression. if the dependent variable is count, so count ang dependent variable, count per unit time or space. For example, number of cases, positive COVID cases for the month of last month, August, for example, per barangay. So we can collect the number of cases for all barangays in the municipality, for example. Then we look for possible predictor variables. So if the distribution is Poisson, so or Poisson regression or Poisson distribution, then we can utilize the Poisson regression. Then if the distribution is negative binomial, then we can utilize the negative binomial regression. Then if the dependent variable is nominal, so the researcher would use this multinomial regression. Then ordinal regression if the dependent variable is ordinal. So the predictor variables can be categorical or continuous. Okay, so this is just a guide for my students. So it depends on you if you will adapt that. So we will focus on the multivariate, many dependent variables with many independent variables. So ito yung mismo yung pinag-aralan natin, pinag-usapan natin since earlier this morning, the path analysis and structural equation modeling. Okay, so about the concepts and applications in research. So we will extend that concepts. Papunta talaga tayo sa research dito. Hindi tayo gagawa dito ng mga derivations of formulas. No. So it's more on applied aspect. Okay, so as I've said earlier, path analysis is an extension of the regression model. It is used to describe the directed dependencies among a set of variables. So there are multiple variables. Kumbaga, kung multiple variables, expect that we have also multivariate data. Kaya path analysis belongs to the multivariate statistical techniques. So during the time of Sewell Wright in 1918, wala pang concepts about latent variables during his time. So in other words, during his time, the variables are considered observed. Okay. So kaso yung application niya, I forgot to indicate in my slides his model. Talagang sa biology siya. So mayroon siyang path model kasi. Okay, so kaso nasa Facebook yata na I was able to post that path model in my Facebook. Okay, so a simple example of path model is the regression. So as you can see, you have the dependent variable, the satisfaction level. We have the independent variables, delivery speed, manufacturer image, overall service. So the delivery speed, manufacturer image, overall service are called independent variables, or we call them predictors. Okay, then satisfaction level. Ito yung sinabi ko na kapag observed variables, regression analysis, yung delivery speed, although mayroon kang mga tawag dito, yung mga items nito, delivery speed. Pero we assume that the delivery speed is observed. Ina-average natin, di ba? For example, delivery speed consists of 5 items. We administer the 5 items, another 5 items for manufacturer image, then another 3 items for the overall service, then satisfaction 5 items also. In order to come up with a regression model, of course, the first step is to produce a global score for each variable. A global score. So, ina-average natin yan. Then, apply the regression model. So, ang tendency niyan, walang error in measurement. What we have only is the error in prediction. So, ang error in prediction, I put that here, this error. So, there is no error in measuring delivery speed. The items, at the item level, wala. In fact, ina-average natin yung mga items na yan. But if we talk about regression, it is an example of a path model. Path model because there is path from delivery speed going to satisfaction. There is path from manufacturer image going to satisfaction level. Another path from overall service to satisfaction level. So we can be able to quantify how much is the proportion of variance in the satisfaction level that is explained by the three variables in the model. And based on this example, it is 64.4%. Then if you look at the coefficient, lahat ng coefficient nandyan ay positive, and nilagyan ko ng dalawang asterisk to indicate that the effect is statistically significant, meaning to say the p-value of that path coefficient is less than 0.05. So the interpretation is simple. If the path is positive, it means that the higher the level of delivery speed, meaning to say the higher the perception about delivery speed, the higher also the level of satisfaction. The higher the perception about the manufacturer image, the higher also the level of satisfaction. Okay, so if the coefficient is the raw data, not the standardized, if the 0.327 is unstandardized, so it means that for every 1 unit increase in delivery speed, the level of satisfaction will increase by 0.327. Okay, so all coefficients are positive. So of course we expect that all are positive. So yung sign is yung sign of the coefficient indicates the direction of the relationship. So yung asterisk, dalawang asterisk indicates that the relationship is statistically significant. Okay, so that's an example of a simple path model, the regression. However, in real life situation, hindi naman siya DVIV lang. So like in this example, self-regulated learning behavior path model, yung self-regulated learning behavior, obviously, ito yung dependent variable mo. If you look at self-regulated learning behavior plus the self-efficacy plus the intrinsic value, obviously, yung intrinsic value and self-efficacy are independent variables with respect to self-regulated learning behavior. But in the same model, this self-efficacy and intrinsic value becomes dependent if we look at the permissive parenting style, authoritative parenting style, and authoritarian parenting style. Meaning to say, this self-efficacy has dual function in the same model. Independent variable with respect to self-regulated learning behavior. At the same time, dependent with respect to parenting style. So that's very obvious. So nakakalito kung dependent at saka independent variable ang gagamitin natin. That is why in the literature of structural equation modeling, pinalitan na yung terms na dependent at saka independent variable. They are replaced by the following terms: endogenous variable and exogenous variables. So endogenous variables, these are variables that are dependent on another variables in the model. So obviously, yung self-efficacy, intrinsic value, self-regulated learning behavior, all of these are dependent on other variables in the same model. So they are called endogenous variables. So the other three, the parenting style variables such as permissive, authoritative, and authoritarian, these are called exogenous variables because these variables do not depend on the other variables. Okay, they are independent variables actually. Okay, so as discussed earlier, our first goal is to formulate our path model. We called it research model. Then we test and confirm. If the data, the sample data and the path model are statistically consistent based on chi-square statistics or other fit indices, then we support or confirm the model, confirm the theory, confirm the research model. If the data and path model are inconsistent, then we look for some possible alternative path models. Okay, so yun yung modeling technique. So a very simple example is like this. This is our, at your left, you can see the conceptual diagram. We call it conceptual framework. Then some other universities call it operational research model. For example, in DLSU, College of Accountancy, they call it operational research model. And some other universities call it conceptual framework. Okay, we start from this. So assuming that there is no, of course, when we talk about conceptual framework, lahat ng variables mo ay naka-connect based on review of literature. Okay, so you use arrows if the existing studies indicate that one variable affects the other. Okay, so in short, the our decision to connect the variables is dictated by the review of literature. Now, if we convert that into a statistical diagram, which we will do that later on this afternoon, so we need to put error in prediction. So E1 and E2 are errors in prediction. So not measurement error, but error in prediction. Okay. Then, of course, based on our discussion this morning, earlier, from here we check the chi-square. However, this is there is distribution. That chi-square, hindi yan chi-square na yung ano natin. So of course, matrix ang pinag-usapan natin dito, yung sample covariance matrix minus the theoretical covariance matrix. The result of that is still chi-square. Chi-square distribution. Okay, kung may stat major sa inyo. So yung ano natin, yung P should be greater than 0.05 so that the data and model are statistically consistent. So in this case, the p-value is less than 0.05, so hindi siya consistent. So I put a note here, fit indices such as root mean square error approximation, goodness of fit, CFI can be used as fit index statistics. Later on, we will have that. Then, of course, this is just an illustration showing to you that if the variables attitude, subjective norm, and perceived behavior are to be connected, the goodness of fit of the model improve. goodness of fit statistics, the p-value. P-value lang ang gagamitin natin just for discussion purposes, but marami yan. Ibig sabihin, if we assume that there is no link among these three in the literature, yung ibig sabihin, mayroong gap. Sa literature, hindi sinabi na yung attitude, subjective norm, at saka perceived behavioral control, assuming na sa literature walang nilagay doon, kaya hindi mo nilagyan yung framework mo. Then, after the gathering of data during the statistical investigation, you found out na correlated pala yung tatlo na yan. So, yun yung i-recommend mo na yung tatlo pala ay correlated. Because if we correlate that, the goodness of fit improves. So the P now becomes greater than 0.05, which is acceptable statistically. So you are confident of that findings. You are confident na pwede ka nang mag-reject ng hypothesis based on that model. Okay, confident ka. Pero of course, check the theory kung logical ba na i-correlate mo yung tatlo. So it's correlation. Okay, so I'm just using that variables, pero of course, sa actual na ninyo na research, magkaibang mga variables. Kaya you check the theory kung talagang yung mga variables na yan ay dapat ba i-connect. Baka walang sense, so do not kasi iba ang sinabi ng data kaysa theory. So hindi ibig sabihin na yung yan ang sinabi ng data, yun na rin ang susundin mo. So you have to check also the theory. Okay, so another one, we have this model. We discussed this earlier. Then we come up with this model. Kaya sinabi ko kanina na you have to check the theory dahil, for example, teacher recommendation. Ang teacher recommendation, may effect ba dito sa school test score? Wala naman siguro. Kaya you should be careful of that. Kaya yun ang nilagay kong example para mag-isip kayo na hindi ibig sabihin na nilagay dyan sa sinuggest ng software, sinuggest ng data mo na ganyan ang arrow. If you have that arrow, the p-value will improve, but it doesn't mean that you have to accept that automatically. You have to counter-check the theory kung may logic ba na yung variable 1 affects the other. Okay. So ito yung sinabi ko sa inyo na goodness of fit or fit indices. So if you look at the table 1, of course I put the source below just in case you are interested of that. Marami namang bago ngayon, but of course ito lang ang available ko, 2003. Evaluating the fit of structural equation models, test of significance and descriptive goodness of fit. So yung chi-square alone, if you use P, the value of P should be greater than 0.05. Okay? Good fit. Pero kung luwagan mo, pwede mo naman gamitan siya ng acceptable fit, which is p-value is 0.5, 0.05 and below. Okay? Then of course, you can also utilize the other statistics like the chi-square. The chi-square should be between 0 to 2 times degrees of freedom. So the degrees of freedom i-produce naman yan ng software automatically. Then i-multiply mo lang ng 2. So number of degrees of freedom times 2. Then your chi-square should not be greater than the product of the degrees of freedom and 2. Then acceptable if the degrees of freedom is or the chi-square is between between greater than twice of the degrees of freedom and thrice of the degrees of freedom. So medyo relax na criteria, acceptable criteria. You can also utilize the root mean square error approximation. So nandyan naman, nakalagay naman yung acceptable fit at saka goodness of fit. Then of course, you can also utilize the SRMR. SRMR, nasa baba naman ang definition kung ano ang SRMR. Standardized root mean square error residual. Okay. So the acceptable range and goodness of fit range are provided. Then kanina nagbanggit ako ng EIC, the Akay Key Information Criterion, as well as the Bayesian Information Criterion. Itong kanilang table 1, table 1 ni Engel and his colleagues, EIC lang ang nilagay. Pero mayroon siyang ECVI. Yung ECVI nila plus the EIC plus the CAIC, so the smaller the values, the better in comparison with the other model. So these are available in AMOS. So the values are automatically computed when we conduct structural equation modeling or path analysis using AMOS. The values of EIC, values of CAIC, values of ECVI are automatically provided by the software. Pag sinabi mong ECVI, so expected cross validation index. Sinabi mong CAIC, consistent EIC. Pag sinabi mong EIC, Akay Key Information Criterion. All of this, the smaller the value, the better the model with respect to the other models, of course. So when we talk about comparison, kasi tama naman yung question kanina na it is possible that we can have multiple alternatives, but the question is which one is the best. So you can utilize the EIC, ECVI, CAIC. Then in AMOS, there is BIC, Bayesian Information Criterion. Okay. So if we talk about path analysis, we can be able to, again, the first one, test if data fit statistically with the model. So we are talking here of covariance-based SEM. So in case of misfit, one can revise or modify the model or find an alternative fitted model, if any. So alternative model is also called modified or revised model. So the inference may be drawn based on the well-fitted acceptable model. Don't make any inferences if you don't have acceptable model. So dapat ang inference mo should always be based on the acceptable model. Hindi yung kagaya sa ibang mga researcher na dahil mayroon ng software, basta lang i-run lang nila, yun na. Hindi po yung ganon. Kaya nga, mayroon tayong major in statistics kasi sila dapat ang i-consult natin just in case mayroon kang problema sa modeling mo. From that acceptable model, the following effects can be tested for statistical significance. So we can test the total effects, we can test the direct effects, we can test the indirect effects, we can test also correlation, we can also test moderating effect. So these are the effects that can be possible if we conduct path analysis. So, ang nasa regression ay puro lang yung direct effect. Diba? And aside from that, if we use regression analysis, limited ka lang sa DV-IV relationships. So in real life situation, hindi lang naman DV-IV. Maaring ang DV mo ay magiging IV din at the same time in the same model. Kaya ang ano talaga, path modeling. Okay, for example, ano yung mga direct effects? Pag sinabi natin direct effects, we are referring to the effect of one variable on the other. Directly from the diagram, you can see there is C prime. So path C is an example of a direct effect. Path A also. So this this path also is also called direct effect. Lahat na yan, direct effect yan. Yan ang definition ng direct effect. The effect of a variable to the dependent variable. It is represented by an arrow from a variable directly towards the dependent variable. Pag sinabi natin indirect effect, there is a definition by Baron and Kenny stating that there is indirect effect if, for example, your IV affects your moderator and your moderator affects your DV. Okay, so if that effect, that combined effect of A and B are statistically significant, it means that there is indirect effect. However, in the literature, yung indirect effect is equal to the product of A and B. So meaning to say, we just multiply the whatever is the coefficient. I-multiply lang natin yan. The result of that is called the indirect effect. And if the indirect effect is significant, then it means that the variable M mediates significantly the effect of X on Y. So yun yung definition. Of course, we will have a intensive discussion about this in the third day kasi mayroon tayong mediation analysis. Kasi yung indirect effect, if it is significant, it means that variable M mediates the relationship between X and Y. Now, testing if variable M mediates the effect of X on Y is called mediation analysis. Of course, we will have a intensive discussion about mediation analysis in the third day. Then, of course, we can be able to compute for the total effect. So the total effect is equivalent to the direct effect plus the indirect effect. Okay, so meaning to say, if M is a mediator, the product of path A and path B is statistically significant, and that product is called indirect effect. The direct effect is C prime. So if we want to compute for the total effect, we just add the direct effect and the indirect effect. Okay, so talking about mediation analysis, napakalayo na ng ilang decades na. So the first approach was proposed by Baron and Kenny in 1986. Their approach is based on regression analysis. There are 4 steps. Okay, then later on, na-imbento na yung bootstrap method, meaning to say, hindi na tayo, yun yung term kanina ni yung nag-question kanina, distribution free. Hindi na tayo dependent sa distribution. So bootstrap method using AMOS. software. Then also, si Hayes, Pritzer and Hayes 2004 developed SPSS macros that has the capability to test for mediation analysis using bootstrap method. Okay, so when we talk about mediation, a very simple example is this. We have the baby's birth weight. Baby's birth weight is our dependent variable. Then mother's age is our independent variable. Then the weight of the mother is our mediator. So alam naman natin na mother's age affects his weight. Hindi naman siya general, but most mothers, yung age nila affects the weight. Habang tumatanda, mayroong pagbabago sa kanilang weight. Then yung weight na yan affects the baby's birth weight. So if this is the model, then we can be able to test if the mother's weight mediates the relationship between age and birth weight. So it is a question mark now, unless mayroon kang empirical data. Mag-gather ka ng data about age of the mother, weight of the mother, and the weight of the baby's birth weight. Then test kung mayroon bang mediation. Okay. Kung nag-exist ba yung mediation dyan. So based on my data, using Amos, ay nakita natin na using my data, mayroong mediation. For example, if we try to check the model, yung 18 na yan, ang tawag natin dyan ay direct effect. So ito yun, direct effect. The direct effect is non-significant because the p-value is greater than 0.05. But yung ating indirect effect, which is 0.75 times the 4.46, the product of that is 3.366, and the p-value is less than 0.05, meaning significant. So the indirect effect is significant. The direct effect is non-significant. Meaning to say, walang direktang effect yung age of the mother on the weight of the baby. Ang age of the mother affects first doon sa weight of the mother. Then the weight of the mother, yun ang mayroong effect doon sa weight of the baby. So indicating that the weight of the mother mediates the relationship between age and birth weight. So yan ang isang application ng path analysis. Okay, so another application is this. We call it moderation model or moderating effect. So there is relationship between X and Y, but there is a third variable, M, we call it M, stands for moderator or moderating effect. That moderating effect, of course, malaking tulong yan para malaman natin kung is the effect of X on Y dependent on M. Okay? Meaning to say, for example, yung M mo dyan ay gender, there is a possibility that the effect of X on Y is strong for female group than the male group, or vice versa. Okay? So, statistically, yung conceptual diagram na yan, this conceptual diagram, the moderation model, can be transformed into statistical diagram wherein the product of the independent variable and the moderator, the product of that becomes the predictor of y. Then if this predictor is significant, meaning to say if the product of the IV and DV is significant, then it means that there is moderation effect. An example of that is the interaction term, yung sa two-way analysis of variance. Ma-apply natin yan kung categorical variables ang ating moderator at categorical variable din ang ating independent variable. Yun, two-way ANOVA. But how about if the variables, the independent variables are continuous? So hindi na natin pwede gamitan ng two-way analysis of variance. So pwede na natin gamitan ng regression approach like that, regression approach, or we can utilize the structural equation modeling approach so that we can account the latent variables in the model. Okay, so we will have a discussion about it the last day, so don't worry. Okay, so I have an example. We have locus of hope sample items. In Tagalog, we have kaya kong abutin ang mga layuning itinakda ko para sa aking sarili. Okay, so nakakaisip ako ng mga paraan para sa malutas ko ang aking mga problema, and so on and so forth. Then we have the quality of life. Okay, so our goal is to investigate if locus of hope has effect on quality of life. Of course, we can do regression for that. If the variables are observed, we can use simple regression. But if the variables are latent, so we can use the structural equation modeling. So if, for example, we are interested of analysis by group, we can analyze the data by group, one model for the male, another model for the female, then compare test the hypothesis that the path coefficient of the male is larger than the path coefficient of the female, or maybe the opposite of that, pwedeng the reverse. But the idea is that using old approach, we can be able to test that hypothesis. Kaso, ang gagawin mo dyan, dalawang analysis. You can do a regression analysis for the male group, another regression analysis for the female group, compute for the path coefficients, then test further if the coefficients are different. Okay, but the yung modern approach of testing moderation is simple. I-drawing mo lang yung inyong diagram, then the software will produce the coefficients. Okay, if the B coefficient is significant, it means that, for example, the B2 is statistically significant, then it means that gender statistically moderates the relationship between locus of hope and quality of life. Okay, so gamit talaga natin yung ating tawag dito ay path modeling approach. Kung ang locus of hope and quality of life ay latent variables, so we can utilize the structural equation modeling approach. Okay, so I think we need to stop here. We need to stop here because it's already 12 o'clock. So we will go back this afternoon. So it's up to you kung what time. So we still have time to for the hands-on this afternoon. On your screen, this is a sample publication na ginagamitan nila ng moderation. For example, PSE. PSE is our moderator variable. Then nag-exist na yung study about PU, perceived usefulness of online buying, intention to buy online, attitude towards buying online, then PEUB, yung perceived ease of online buying. Then yung kay Iconaro 2013, dinagdag lang niya yung variable na PSE. Yan, as his or her moderating variable. Then na-publish na. Okay? So that's the application of moderation model. Okay, this afternoon we will proceed to the hands-on using SPSS AMOS. So just in case you have questions, so please don't hesitate to ask questions. Okay, pwede na tayo mag-lunch.
Opo, sir. Mag-entertain na lang po tayo ng questions pag resume po natin.
Okay.
So,
Sorry sa time, lumampas ako.
Okay lang po. Dear participants, we will be resuming around 1:05 na lang po. 1:05 p.m.
Sige po.
Thank you. Have a
Thank you.
great lunch.
Thank you, sir. Okay, good afternoon, everyone. Let's proceed to the hands-on path analysis using AMOS, SPSS AMOS. So as a continuation of our discussion this morning, let's proceed to the path analysis using SPSS AMOS. So the latest version of AMOS is 27. But if we talk about path analysis, even if version 23, we can still perform path analysis. There are slight improvement for every version. Most of the improvements are on the colors of the diagram, so something like that. So as I've said, the improvement per module is just slight, not significant. So in other words, whether it's 23, 24, 25, 26, or 27, we can still produce same results when it comes to path analysis, structural equation modeling, and confirmatory factor analysis. So for this afternoon, let us try to, I would like to introduce first the software. So AMOS stands for Analysis of Moment Structures. So AMOS is a software for structural equation modeling. It is different from R because AMOS uses a graphical language, no need to write equations or type commands. Unlike are in AMOS, we just draw the diagram. Literally, we draw the diagram. AMOS has a drawing canvas. We have tools like rectangles, ovals, arrows, something like that. All you have to do is to draw our diagram on the drawing canvas. We don't need equations or commands. So it's user friendly because it can we can utilize AMOS even if we are not statisticians. As long as we understand the concepts, we can be able to do the analysis. Okay, so this is the screen. If we open our AMOS, we have these drawing tools. In the left side, we have the oval, we have the rectangle, we have latent variable. So obviously, this is the object, or this object represents the latent variable. Then we can also erase, just in case we want to erase. We can also move. We can also move an object from one place to another by using this cart. We can also rotate, so and many more. We will apply this when we analyze our when we conduct path analysis for our example. Okay, so if you look at the drawing canvas now, so yung parang may white space, so that corresponds to a short size bond paper. So it can be the orientation can be changed. For example, the default is portrait. We can change that to landscape. We can also change the colors if you want. If we want, the default is white. Okay. So for example, we have this path model: current salary, beginning salary, education, age, gender. We can literally draw the diagram in AMOS. Then after the drawing, of course, we need to link our data. We should inform SPS. We should inform the AMOS that we have data set. For example, our variables: educational level, SALBEG, sex, we have age, SALNOW, work experience measured in terms of years, salary now or SALNOW, we have SALBEG. So these are expressed in dollars. Then age in years, we have educational level in terms of number of years of formal education. Then we have also time. This refers to the number of months since the employee was hired by the company. So it is equivalent to length of service. So 88 months. So the first respondent is 88 months already in the company with an educational level of 12 years. Then beginning salary is $5,400. Then after 88 months, the salary becomes 10,680. So there is increase from beginning salary up to the current salary after 88 months. Then prior to joining the company, this person has already work experience. So for example, 3.17 years. Okay, so this is the raw data that we want to raw data as a requirement when we do path analysis or structural equation modeling. Okay, so we can also provide, or we can also summarize the data as our input. For example, if we have already the covariance matrix. So lahat na entry dito, data natin dito are covariances of the variables. So our variables are C5, C4, C3, C1, if1, and so on and so forth. Then the first row represents the sample size. Then the entries here below, below the the numbers below the sample size are covariances among the variables. So that is why there is COV, covariance. The nice of structural equation modeling is that we can ask the researcher to append the matrix, this kind of matrix. So optionally, we can utilize the correlation. So if correlation data are available, we can change COV to COR, correlation. But since it is correlation, we need to indicate the standard deviation below the mean. So yung last row kasi mean. If we used covariance matrix, so only mean is required. But if we use correlation, we add standard deviation below the last row, below the mean standard deviation. So in other words, this correlation matrix or covariance matrix is our input if we conduct covariance-based structural equation modeling. Or if you don't know how to create this file, you can just utilize the raw data like this. So the raw data, of course, if you are a user of SPSS or any software, mabilis lang naman. So ang AMOS can read Excel files. So for example, if you don't have SPSS, but you have AMOS, kasi stand-alone SPSS package ang AMOS. If you have no SPSS but you have AMOS, you can save your file in Excel. Excel files can be accessed in AMOS. Okay, so this is the screenshot of an output, AMOS output with standardized coefficients in the diagram. We can request SPSS to indicate in the diagram the standardized coefficients, the unstandardized coefficients, the chi-square, the values of the fit indices, and pwede tayong maglagay dito ng title if we want. Okay, so there is just a command on how to indicate all this. Itong chi-square, root mean square error approximation, and other fit indices. Pwede tayong ita-type lang natin yan. Then the AMOS will produce the results. So as I've said, the AMOS can produce unstandardized coefficient. Then we can also request the software to produce the standardized. So here we have this, in this panel we have standardized estimates, then we have unstandardized estimates. Okay, then of course after that we can also request the text output. So in other words, AMOS can produce outputs in terms of diagram, output in terms of tables like this. So in the tables we can see the estimates, the parameter estimates, regression weights, the standard error is the critical ratio. Critical ratio is just the quotient between estimate and SE. Then we can also have the p-value. The p-value less than 0.001. Tatlong asterisk ang lilitaw kung less than 0.001. Okay, so that's the the regression weights. Then also we can request the fit indices are plenty. So for example, p-value, C mean stands for minimum chi-square. Yan, no? Mayroong minimum chi-square, number of parameters in par, number of degrees of freedom, the minimum chi-square divided by the DF. Okay, kanina mayroon tayong chi-square should be less than or equal to twice the standard deviation. Diba? May ganon kanina. Or the chi-square should be between twice of the degrees of freedom and thrice, 3 times degrees of freedom. So mayroong ganun doon sa ating table 1. So yung table 1 natin, yun ang ating reference when it comes to goodness of fit or model fit summary. We have also the GFI, AGFI, and so on and so forth. So notice that there are 3 models. We have default model, saturated model, and independence model. So yan yung i-discuss natin, yung default model, saturated model, and independence model in the next slide. So when we say default model, that is the model of the researcher. So if you are the analyst, the default model is your model of the analyst. So when we say independence model, this is the model where there are no relationships between the variables. So it is assumed that all variables are not correlated. So therefore, it is considered as the worst model. So we put that worst model at the left side. Okay. Then there is a saturated model, a model which fits the data perfectly. It has no degrees of freedom kasi lahat ng mga variables mo ay naka-connect. So there is no degrees of freedom. It is considered as the perfect model. So we put that at the right side. Then, in other words, the goal of the researcher is to look for a model that is very close to the perfect model. So this is now this is you. This is the default model. This is our model as analyst. We don't like that this model ay malalagay dito sa close to the worst model. We want that our model is closer to the perfect model. The default model, the goodness of fit or the fit indices are close to the perfect model if, for example, the p-value is greater than 0.05. Another example, if the root mean square error approximation or the RMSEA is less than 0.08, so closer to the perfect model yan. Pero kung napakalaki na ng value ng fit indices, for example, root mean square error approximation ay close to 1, so nasa worst model na siya. But if it is less than 0.08, based on our reference, close to the perfect model siya. Okay, so just refer always to the reference that I provided, or much better if you have latest reference about goodness of fit. But theoretically, yun yung purpose kung bakit nilagay nila yung independence model, saturated model, default model, so that the researcher can compare For example, the default model here is ang chi-square niya ay 5.040. Obviously 5.040. Yung saturated model always 0, meaning to say walang discrepancy ang data at saka model. The difference between the sample covariance matrix at saka theoretical covariance matrix ay 0. Yun, 0. If the variables in the model are assumed uncorrelated, yun yung pinaka-worst model. The chi-square, the minimum chi-square is very large, 1,222.0014. Then, yan yung left side. Yung right side natin is 0. Saturated, yung perfect fit. Pero yung default model natin is very close to the saturated model. Kaya to let you understand, nilagay kong ganyan. Okay? So, we want, as a researcher, we want that our model, our default model is closer to the perfect model. Okay? So, malalaman mo kung pangit yung model mo kasi closer ang kanyang chi-square, closer to the independence model. Kung titingnan mo naman yung, say for example, GFI, goodness of fit, ang perfect fit has a GFI of 1. Tapos ang independence model, ang kanyang GFI ay 0.569. Pero yung sa'yo, yung default model mo is 0.996, closer to 1. So you are confident of your GFI, closer to 1. The same also with AGFI. So AGFI of 0.926, closer to 1, is considered as acceptable. If you look at the discrepancy between independence model and the default model, so malayo ang agwat nila, di ba? If you look at also the other, say for example, CFI. So for the perfect model, the CFI is 1. For the worst model or the independence model, 0. Pero yung default model mo close to 1. So, ibig sabihin, maganda yung fit indices ng model mo. Okay, so this is just the concept about the goodness of fit or fit indices. Let's try this model. Just familiarize. By the way, I already sent to Sir, sino ba yung kausap ko? Si Sir Renato. I already sent to him the link of the data set as well as the slides for your copy. So if you like to, for example, after my demonstration, kasi gagawin natin ang demo, live demonstration, how to conduct path analysis using AMOS. Live ito, so I will perform the analysis live. So gagawin natin yan. So education, age, work experience. Actually, that is really my I always offer. Before the pandemic, we had several sessions with PARSU, Philippine Association of Researchers and Statistical Software Users. We had almost every month, I conducted a workshop about structural equation modeling here in Metro Manila. Kapag live, face-to-face, ma-monitor ko kung sino yung hindi pa tapos. I can assist because during hands-on, we have training assistants umiikot. For example, 50 participants in attending the training. So mayroon kaming training assistants. The training assistants will assist the participants kasi hindi naman nakikita lahat ng 50, hindi nakikita ng resource person kung sino yung hindi nakasunod. Face to face yon. So kaya yung mayroong research assistant na umiikot. So ngayon, since this is virtual, I cannot see you if you you can follow my you can follow the hands-on. So the best approach is to save the video recordings. You can ask the video recordings from your IT, so that after our session, after our live session, you can be able to give time to practice on how to perform the analysis using AMOS. Okay, so our file is employee.sab. So kapag employee.sab means that it is SPSS file. It has a sample size of 474. Then the variables are current salary, beginning salary, job seniority, education, age, work experience. Assuming that these are our hypothesis, we have H1, H2, H3, and so on, up to H9. So notice that each path has a corresponding hypothesis. Yun ang uso ngayon sa mga publication. Then of course, we all know that for every path there is a hypothesis. So ibig sabihin lang ng H1, if we express that in words, educational attainment affects beginning salary, SALBEG. So this is alternative hypothesis, not the null. Okay, so you can express this in words when you write your manuscript. So yung H2, H3, H4, lahat dyan ay direct relationship or direct effect muna. So hindi muna tayo mag-mediation, one at a time tayo. So direct effects muna yan. As discussed this morning, direct effects are effect of one variable on the other. Okay? So yan, for example, H1, effect, direct effect yan. Education on beginning salary. Okay? Then, of course, we expect that there is path coefficient from education to beginning salary. So when it comes to assumptions, of course, I read somebody posted his question about assumption. Of course, dahil itong covariance-based SEM ay parametric test, so always, as always, yung assumption natin sa regression analysis ay ganon din dito sa structural equation modeling. For example, yung Bian assumptions, yung mga multi-collinearity issues. So we can still explore first our data before we proceed to the path analysis. So yung mga usual natin, mga outliers, you can check that multivariate normality. You can check also that marami naman tayong software that can handle multivariate normality. For example, is R. So mayroong multivariate normality sa JASP, mayroon. Dito sa AMOS, mayroon tayong multivariate kurtosis, multivariate skewness. Mayroon din tayong Mahalanobis distance to test for the outliers. Okay? So, I will leave that to you kasi basic naman yan sa regression. So, we don't have time for that yung mga assumptions, but you can, of course, that would be your priorities. Then, of course, when I said priority, so you should explore first the data. Then after the analysis, you can also do some validation or checking of the assumptions. Yung magandang software natin, yung WAR-PLS, nandoon lahat sa output. For example, if in just after clicking the compute, the all statistical test, including the normality, multivariate, mga fit indices, nandoon na lahat. Ito lang AMOS, medyo ano siya. Nandiyan na rin, pati mga multivariate, pero kailangan mo i-request. Okay, so let's proceed. Okay, so madali lang naman ang AMOS. So, for example, you open the AMOS, open the data file, draw the empty boxes muna, then connect the boxes with arrows, type the variable names on the boxes, draw the error terms. Lahat na to, you can do this not necessarily in or correct order. You can do this at random, kung kahit ano alin dito ang in any order. I mean, in any order. As long as you draw the boxes, connect the boxes, and so on and so forth. Draw the errors. Then, of course, do not forget that number 10, we test the model, the global fit and parameters. If necessary, we revise and improve the model, then interpret the results. Okay. So, testing the model. So, global fit and parameters. To do this, we calculate the estimates. The global fit statistic, such as chi-square test, should be non-significant to be an acceptable fit. Improve the model in case the p-value is less than 0.0105. Use the alternative indices in case non-significance of the chi-square cannot be attained. So meaning to say, since this is a parametric test, ang gagawin mo, check po ninyo yung ano muna, yung mga outliers. You can utilize the SPSS when it comes to outliers. Then, ibig sabihin, bago mo, before you conduct path analysis, nag-explore ka na sa data. So, data cleaning is the first part. Sabi nga nila, data cleaning spends about 80% of your time. So bago mo isabak ang data for path analysis, dapat nilinis mo muna. So ibig sabihin, kapag ang p-value mo ay less than 0.05, nag-conduct ka na ng path analysis, dapat malinis na. Okay. Use the alternative fit indices in case non-significance of the chi-square cannot be attained. Fit indices are presented in the appendix. So a model being tested is constructed based on theory. So kapag hindi theory-based yung model mo, huwag mong gamitan ng covariance-based. My suggestion is use the PLS-SEM. Kasi ang PLS-SEM, as discussed this morning, it is useful if the goal of the research is prediction or exploratory. So meaning you don't have theory. If theory testing or theory confirmation, use the covariance-based SEM. So using our AMOS, ito na yung result. So results of the proposed model. The chi-square is obviously 553. Mayroon tayong degrees of freedom na 6. Then mayroon tayong p-value na less than 0.05. Yung degrees of freedom dito sa structural equation modeling or path analysis, ito yung path na hindi kasama sa model. Halimbawa, hanapin natin yung 6 degrees of freedom. Yung 6 degrees of freedom ay number 1 na yan, yung path from say for example, path from work experience going to current salary. That corresponds to 1 degrees of freedom. Another one is the path from beginning salary or job seniority going to beginning salary or vice versa. So that's another one. So education also is another one. So that's another degrees of freedom. So nakatatlo ka na. Then of course, mayroon ka pang age. You can connect age to education, double-headed arrow. So correlation yan. Okay. So that's another degrees of freedom. Then work experience to age. So that's another degrees of freedom. Then finally, we have the work experience going to education. That corresponds to another degrees of freedom. So if you count the number of degrees of freedom, 6. So kung i-drawing mo yung lahat ng green na yan, kung ganon ang framework mo, you expect that your degrees of freedom is 0. And since you did not connect, wala ka namang arrow nag-exist sa actual data mo, so meaning to say yung green arrows, yan yung degrees of freedom mo na 6. Okay? So results, may label ako ditong nilagay. Results, data and model are statistically inconsistent because the p-value is less than 0.05. So action, don't use the model. Modify, improve the model. So to improve that, of course, diniretso ko na, this is just an example. But later on during our hands-on, we will do that step by step. So look at the model number 2. We call it improved model. So the software suggests that education and current salary should be connected by arrow. Then age, work experience, and education should be correlated. If you do that, the chi-square will reduce, magiging 4.709, and the p-value now is greater than 0.05. So tama po, kanina may nag-comment na trial and error. Kung malaki ang model mo, trial and error, mahirapan po kayo. Pasalamat tayo sa ating software dahil the software has the capability to suggest kung alin ang i-click mo, alin ang ilagay mong path so that the chi-square will decrease. So ang tawag natin dyan ay modification index. So the amount of chi-square, amount of reduction in the value of chi-square is called modification index. So for example, kanina without that double-headed arrows at the left, without this path from education to current salary, ang chi-square mo ay 553.479. Now, kung i-drawing na natin yung i-connect na natin yung age, work experience, education, at saka magdagdag tayo ng path from education to current salary, the p-value improves. The chi-square reduced to 4.709 from the original na 553. Okay? So in this case, the result, I put the label, data and model are statistically consistent. With a chi-square of 4.709, then p-value greater than 0.05. So action, use this model to make decisions about the hypothesis. Number 2, produce a trimmed version of the model. If your goal is to produce a model talaga, yung model na clean, meaning to say clean, all path coefficients are statistically significant, so you can trim, you can produce a trimmed version of the model. Trimmed version meaning we remove the non-significant path. So ang gagawin mo, dahil halimbawa kung thesis yan or dissertation, i-report mo yan dahil acceptable naman yung fit, acceptable mo naman yung fit. You can report that because yung first 11 or first 9 hypothesis, yan yung hypothesis mo. Okay? So, of course, you can decide whether the hypothesis is to be supported or not. Remember na yung H1, H2, H3 na up to H9 na nag-appear dyan ay hindi siya null hypothesis. So, lahat na yan ay, kung baga ang tawag natin dyan ay alternative hypothesis. So, masasagot natin yung ating original hypothesis from H1 down to H9. Okay, so we can answer that. Ibig sabihin kung thesis or dissertation, then you defend that to your panelist, to your advisor. So yes, you can answer that. But there is additional path. I call it new path because this new path was discovered only during the data analysis. Okay, so this new path is significant because the p-value is less than 0.05. So yung H4, H5, and H6 mo ay not supported. Okay, yan, malinaw yan. Pati yung H2 not supported. Okay, so ngayon masasagot na yung hypothesis mo, di ba? Kung thesis or dissertation yan, you can be able to address your research questions based on that results, plus additional path na may considered as extra because it was not part of the framework. Ngayon, of course, babalikan natin yung framework mo because you need to add a section in the last section in the results as your emerging model. Ibig sabihin yung original model mo ay yung original framework mo hindi nag-work. So, ang nag-work ay yung yan, yung bago mo. So, you have to develop or you have to add you have to insert additional section in your results. Sa DLSU kasi ang results ay isang chapter, another chapter for the discussion. I don't know dito sa PUP. Okay, so for the data and model statistically consistent, of course. Ibig sabihin tinanggal na natin yung mga non-significant path. Tinanggal na natin, then the more that p-value ay lumaki, the more that the p-value improves, the more that the root mean square error approximation improves, the more that the GFI improves, the more that the CFI improves. There was a question earlier kung mag-improve ang p-value, mag-improve din ba ang mga other fit indices? The answer is yes, because the other fit indices are chi-square based also. Ina-adjust lang yung mga values ng, for example, GFI, CFI, ina-adjust lang ang formula because chi-square is sensitive to sample size. So para hindi na siya dependent sa sample size, kaya inimbento yung ibang mga fit indices. So your action is discuss that the research model is inconsistent with the data, meaning to say your original research model is inconsistent with the data. Therefore, it is modified. Model 3 is our recommended model. So meaning to say, this is your model. Ito yung i-recommend mo sa paper mo na ito yung model. Hindi yung framework mo in the beginning. Dahil yung framework mo in the beginning, hindi yung nag-fit. Bakit i-report natin yung ano na hindi naman yung nag-fit? So ang i-report natin yung acceptable, yung model na acceptable fit, na may acceptable fit. Okay? So let's do this using Amos. So I will go out from here. I will open my Amos. Okay, so this is my Amos, but I want that the Amos is clean. So it's I have this new. Do you want to save? So I said no. So this is now the the Amos. Kung bubuksan mo ang Amos, so we can say, for example, you can enlarge or zoom in, zoom out. Then, for example, you don't like the color of this drawing canvas. Tawag natin dyan, drawing canvas. If we don't like this, we can click view, then interface properties. We can change the size of the paper. So the default is short size when paper, then portrait. Then we can change this, for example, gusto mo ay landscape, for example, apply. So it's something like that. Yeah, landscape, yeah. So kung liitan mo, so it's a landscape, short size but paper. Then if, for example, you don't like the color, so you change the color. So you just click interface properties, then click color. So you have now the, for example, background. You want to change the color. Change to, say, for example, yellow, if you want. Something like that. Okay. Then the default is, default natin dito is white. So for example, gusto mo ay dark salmon. Ano ba yung dark salmon na yan? Okay. So just apply. Something like that. So for example, we just change that to another color. Say, for example, maroon. Yan. Pero hindi na masyadong makita kung maroon. Sa mga publication, white lang naman yan. So, white lang. Sa mga publication. Not necessarily na colorful. The most important in the publication is the content, your writing style. Okay, so of course, the first step is to inform your Amos about your data. So ang gagawin natin, titingin muna tayo sa data. So our data is SPSS file. So we can open the SPSS file here, or pwede din natin buksan using our SPSS if we want. So ang aking SPSS ay yung bagong innovation. So it is part of the PS Imago Pro. Inside PS Imago Pro is SPSS. Yun yung bagong innovation ngayon. Okay. So in just a matter of seconds, depends on the speed of our laptop. Okay. Okay, so ano lang naman, hindi naman aabot ng 1 hour yan. Okay. So it's still loading. Okay, so we have now the SPSS. So I can open now my file, data. Then I have a PUP folder in my desktop. So employee. Okay, so this is the actual data. What I have is raw data. We have education. We have the beginning salary. We have the job seniority, the time, number of months since the employee was hired by the company. Then we have the age also in years, then the current salary, then work experience. Then we have extra um, demographic profiles such as gender. Then we have also job position. So these are the variables. Then this variable, this data set contains 474 employees. Okay, so 474 employees. Okay, if um, of course after this we open our Amos, we go back to our Amos rather, then we inform Amos that our file is employee. So just click file, then data files, then file name, then go to the desktop, go to my folder, POP folder, then click employee. In short, just provide the file name. So employee, that is AB, contains 474 people, 474 rows. So it is now connected. We can now click OK. Then after that, you can go to the list of variables. So the list of variables is this icon, list of variables. If you click the list of variables, you can see the list of variables here, including the educational level, beginning salary, time, age, and so on and so forth. You can also see the label, education, beginning salary, because the SPSS, if we go back to the SPSS, we click the variable view, you can see the variable names in the first column. You can also see the labels, education, label. For example, what is the meaning of salve? So we can have this beginning salary. Okay. I suggest paki-mute yung ating para maganda yung recording. Okay, thank you. So yung ating label dito sa SPSS, nag-reflect din doon sa Amos. So napansin nyo? Yan. Okay. So we have the complete list. We have education, Salbeg, we have the age, we have the Salnow, the work experience. Okay. Now we have two ways on how to draw the diagram. We can utilize the drag and drop, meaning to say, pwede natin i-drag. So for example, we drag first the Salnow. Kapag gamitan natin ng dragging, i-drag natin yan, we drag this to the drawing canvas. Yung label mismo ang lilitaw, current salary. Then for example, Salnow. Yan. Next is, say for example, the time, the job seniority, put it here. Then another one, we have the education, for example, move natin yung education. We move also the age. Then we move also the work experience. So that's one way of drawing. So, however, as you can see, hindi maganda yung mga position nila. So, your next step is to use the cart. Itong cart na to, move objects. We use this because we want to move the objects from one place to another. So, for example, job seniority, ilalapit mo. So, something like that. Then, lalapit mo rin to. Okay? Something like that. So, the next step is you don't like the size of the rectangles. The size of the rectangle should be similar, uniform. Ayun yung concern mo. So, madali lang. You can click this icon, drag properties from object to object. Then, kung gusto mo ang size of the boxes are uniform, so click mo lang yung height and width. So, height and width of the rectangles. So, alin dyan ang which size ang gagayahin mo? For example, you want to copy the size of current salary, yan ang i-drag mo papunta doon sa mga box. Yan. So, para mag-adjust yung size. So, the sizes of the boxes are now uniform. So, we can close this. The next is to connect all the boxes in accordance with your framework. So we can use the single-headed arrow. So based on your framework, mayroon kang education to beginning salary. We have also path from education going to job seniority based on our framework. We have age to beginning salary, age to job seniority, then work experience to beginning salary, then work experience going to job seniority. Then further, you have also this path. We have also this path. Okay. Then we have also this path. So parang ganyan yung ating drawing kanina. So using the cart again, pwede mong i-adjust. Kung gusto mong i-move forward, feel free to move forward using the cart. So yan, yung arrangement ng mga the arrangement of the variables ay kayang-kaya yan sa AMOS. Okay. So after this, we need to think that this is the equivalent of our framework, but we need to add more because our drawing here is the statistical diagram. So that the software can continue to produce the estimates, we need to put prediction error dito sa current salary, beginning salary, at saka job seniority. So we call it error in prediction. So the error in prediction is this icon. Yan, that icon. Go to the box, then click. Go to the box, then click. Go to the box, then click. So for example, job seniority, gusto mo sa labas ilagayan yung error term niya. Pwede mo yan, you go to the box again, then click several times. Iikot yan. If you click several times, iikot yung error term na yan. So, yung error term na yan, masyadong maiksi yung kanyang arrow. Pwede mo naman i-move upward. So, notice that there is one automatically the coefficient of that is 1. Because if, for example, titingnan mo yung equation ng regression. For example, regression equation. Current salary equals B sub O plus B1 times the beginning salary plus B2 times the age plus B3 times the job seniority plus the error term. Di ba plus the error term mayroong coefficient na 1. Doon automatic na the coefficient of E1 is 1. Okay? So we put a label also in the error term. Okay? So to put the label, ang gagawin nyo, you go to the, pwede mo na i-unselect na to, yung object. You go to the oval or the circle, right-click mo, then object properties. So in the object properties, pwede ka mag-type ng E1. Then click the next error and prediction, then you type E2. Then type E3 for the next error term. E3. Ayan. So it's manual, di ba? Later on, of course, I will teach you how to put labels automatically. Kasi mayroong automatic. Okay? So ngayon, ang drawing natin ay tapos na. So perhaps we need to add, say for example, title. So yung title na yan, just click the title, then go to the drawing canvas. Ang goal natin dito is to i-type natin yung, say for example, chi-square. The value of chi-square. It is a command. We have letter C, then mean. Meaning to say minimum chi-square. Then comma, degrees of freedom equals backslash degrees of freedom. By the way, do not forget to put backslash before the word CMIN, before the word DF, and before the word P. So P stands for P value. If you have this command, yung backslash P, backslash DF, backslash CMIN, yun yung command so that Amos will compute, will provide the value of P, will provide the value of DF, provide the value of CMIN. Then below you can add more fit indices, for example, root mean square error approximation. Okay, backslash ulit. Then we have root mean square error approximation. Hindi naman siya case sensitive. Pwede siyang small letters, pwede siyang capital letters. Okay, so we can also type GFI, goodness of fit index. Pero mayroon kang dapat na backslash then GFI. So again, pwede siyang small letters, pwede siyang capital letters. So dagdagan natin ng CFI. Okay, so we have backslash CFI. Okay, so yan muna. Then of course, nakalagay yan sa center on page. Pwede natin i-left align. Then click OK. The left alignment is very important so that we can move. Pwede natin kahit saan ilagay yan. Okay, so for example, dito mo ilagay yan. Okay, so we are done. So after this, we save our work. So file, then save as. So perhaps we can use the file name PUP model 1. So this is our first model so far. Okay, so it is already saved. So in fact, yung model 1 nandito na yan, PUP model 1, nasa baba na. The next step is to request AMOS to produce the standardized. Kasi mayroon ditong unstandardized, mayroong standardized coefficients or estimates. So we can click, for example, view, then analysis properties. In the analysis properties, you can see the standardized estimates. You can see the squared multiple correlations. So these squared multiple correlations are basically the R squares. Yan. Then, din na lang natin yan. You can also click the test for normality if you want. So mayroon dyan mga test for normality. But our goal now is to apply the other kasi hindi natin na rinig yun sa regression analysis. Wala namang modification index. So later on, I will discuss kung ano yung 4. But in the meantime, let us nag-eco. Okay, so just in the meantime, let us check the modification indices, standardized estimates. Then the default of this is the maximum likelihood. Okay. Okay, so we can go out from here. We just click X, meaning to say i-close na natin. So just click X. Then after that, we can ask the software to calculate. So in the analysis, in the analyze menu, just click then calculate estimates. Okay. Then there is a warning, AMOS warning. Sabi ni AMOS, AMOS will require the following pairs of variables to be uncorrelated. So in other words, since your framework did not draw or did not indicate the double-headed arrows for the education, age, and work experience, nire-remind ka ng software. AMOS will require the following pairs of variables to be uncorrelated. They are uncorrelated because you did not draw here. So if that is correct, then you can just proceed with the analysis. Okay? So in just a matter of seconds, tapos na ang computation. I know that the computation is already done because of this red arrow. The red arrow signals that the computation is already done. If I click this red arrow, so the coefficients appear on the diagram. So pwede kong lakihan yan, so that you can be able to see. So napansin nyo, mayroon tayong standardized estimates. We have also unstandardized estimates. Okay? So the unstandardized estimates, yung 752.31, this is similar to regression, ang interpretation niyan. Meaning to say, for every 1 year increase in education, the beginning salary will increase by 552.31. Diba? Ganon ang regression na linear regression. Ganon din dito. Kasi yung AMOS linearity. So of course, yung titingnan mo rin yung linearity assumption. So gagawin mo yan sa SPSS if you want. Kasi dito sa AMOS wala siyang test for linearity. Okay? Okay, so ano kasi ang SPSS negosyo ang dating. So since if we conduct path analysis, one assumption is linearity. So para ma-test mo yung linearity, bibili ka ng SPSS base. So doon mo i-analyze yung linearity. Okay? So notice that the chi-square is 553. Yung degrees of freedom natin ay 6. Yung p-value natin ay less than 0.05. Yung root mean square error approximation natin hindi siya acceptable. Kasi ang minimum acceptable value of root mean square error approximation based on our reference earlier is 0.08. So below 0.08 is acceptable, but our root mean square error approximation is 0.439. Tapos ang P natin ay hindi siya acceptable because it is less than 0.05. So dapat greater than 0.05. Okay? So what shall we do? We look at the text output. So the text output can be viewed in the click view. Then you can see the text output here. Kita natin text output. Just click mo lang. Click mo lang yun. Then of course, nakaseparate sa akin. Yung pink na yan, just click that. Then you can see the, say for example, analysis summary. Nandyan yung date to day. Then notes for the groups. We have the model is recursive, 474. Variable summary, you can see the observed endogenous variables, salvig time, salnow. Then observe exogenous variables, the educational level, age, and so on. Then you have unobserved exogenous variables, the error terms. Ito yung we manually draw. We manually put the label E1, E2, E3. Then below you can see also the number of variables in the model, number of observed variables. Then of course you can have also this parameter summary. So how many covariances, how many regression weights. Okay. Then of course the model note. So the number of distinct sample moments, the number of distinct parameters to be estimated, degrees of freedom, then the value of chi-square, the p-value, and so on and so forth. We are interested, of course, on the estimates. Okay, so in the estimates, you can see the regression weights. For example, our diagram contains the educational level going to, pakita natin yung diagram natin. We minimize this. Then also, we minimize also the text output. Okay, so the diagram now, as you can see, there is a path from education going to beginning salary. The coefficient is 752.31. So the text output tells us also that the path coefficient is 752.306. So round off 0.31. Then you can see also the path from educational level to time. So education to time is basically job seniority. It is 0.22. So 0.22. Then age to beginning salary is 3.06. We have also 3.059. Okay, so if you want the gusto mo ang if you want the standardized, just click this for the standardized. Then halimbawa ayaw mo yung placement nung halimbawa 0.22, hindi malinaw kung para saan yan, which path. So we can modify or we can move parameter values. Yan, 0.22. Ito ay 0.75. Okay. So, para pala yan dito sa path na yan. Okay? Okay, so ngayon kung ano natin yan, standardized. So below, you can also see the standardized regression weights. So for example, path from educational level going to Salpec. So this path, 0.67. So you round off this 0.67. If you round off this educational level to time, education to time is 0.06. If, for example, you want to know the age to, say, beginning salary. So age to beginning salary. So it's here, 0.01. So we have 0.01. Okay? So yan yung text output natin. Now, of course, because the yung titingnan natin yung model fit. You can see the minimum chi-square. So as discussed earlier, this is your model, default model. The chi-square is 553.479. The independent model, ito yung pinaka-worst model. So the value is 1610, the minimum chi-square. Pero ang saturated model, this is the perfect model. The chi-square is always 0. So yung 553 is closer to the saturated model. Okay? So tingnan mo kung closer ba siya. Saan siya closer? Sa independence model or sa saturated model? Closer, but it is not yet acceptable because the p-value is still less than 0.05. Okay? If you look at also the root mean square error approximation, the value is 0.439. The acceptable is 0.08 or below, based on our reference earlier. So indicating that the model, yung model natin, hindi siya acceptable. So meaning this diagram is not yet our final. Hindi pa siya, this model is not yet acceptable statistically. So meaning our data and model are statistically inconsistent for now. So hindi pa natin niya pwedeng i-report yung results na yan dahil wala ka pang tiwala sa model. Okay? So we need to improve. We go back to the text output. So earlier dito tayo kumuha ng view then text output, di ba? We can also click this kasi ito yung direct na view text output icon. So i-click mo lang ito. Then go to the modification index. So the modification index is very important because this is our the suggestion of the software. For example, if you draw a double-headed arrow, okay, so let's show the diagram. Sabi dito sa modification index, if you draw a double-headed arrow from work to age, the chi-square will reduce by 306. So meaning if you draw a line, double-headed arrow from work to age, the chi-square will decrease by approximately 300, more than 300 points. The chi-square will decrease by 306.234. Yun yung ibig sabihin dito. If you draw also another double-headed arrow from work to education, the chi-square will decrease by 30. So kung i-add mo yan, 30 plus 306 plus 30, so mayroon ka ng 336. Approximation yan. Then if you draw another one, say for example, educational level to age, education to age, so it's another 36 reduction in the value of chi-square. So ang gagawin natin, one at a time. Para mag-increase yung ating P, gagawin natin is one at a time. For example, we start from the largest MI. Okay, so the largest MI is work experience going to age. So yan ang gagawin natin. So we go back to the diagram, then we draw the path or double-headed arrow from age to work experience. So it's correlation. Correlation yan. Correlation between work experience and age. Okay? Then calculate ulit. Proceed. So the computation is done. So your chi-square now is 60. It is now reduced to 60, but your p-value is still less than 0.05. So your root mean square error approximation now is reduced to 0.15. Kanina is 0.4. Ngayon ay 0.15. Yung CFI mo at saka GFI now are close to 1. So 1 is the highest value of GFI, CFI. So after this, since there is improvement, we can go back to the text output. So the text output can be viewed either this text output icon or click view, then text output. So here we have the modification index again. So napansin nyo, ang suggestion na lang ng software natin ay mayroon tayong age to educational level, age to education, plus the below mayroon pa siyang regression weights. We have educational level to SALNOW. Now if we draw the age to a double-headed arrow, age and educational level, the modification index is 7.7, meaning to say the chi-square is expected to reduce by 7.7. Now if we draw the line from education to SALNOW, the chi-square will decrease by 8.288. So dito tayo sa malaki. Okay, so SALNOW daw, education to salary now. So i-minimize lang naman natin yan. So we go back to the drawing, to our diagram, so that we can be able to modify. I-click natin yung arrow beside the red arrow. Yan. Then click the one-headed arrow. It was instructed earlier that if we draw education to SALNOW, there is a reduction in the value of chi-square by about 8 something. Okay, so after this, i-maximize ko lang. Yan. After this is calculate. After ka naglagay ng arrow, calculate ulit. Calculate estimates. Then proceed with the analysis. Click the red arrow. So the root mean square error approximation now is 0.14. Yan. Mayroong mga pagbabago, so balikan natin yung modification index ulit. Modification index. So modification indices. So we have now another suggestion, age to educational level. So if we try to connect age to educational level, we expect reduction. Calculate ulit. Proceed. Then view again. So we have now the p-value. The p-value is still 0. So I think we need to review education, age, and work experience. So yung age natin, okay. So there is improvement in the GFI 976.973. Then our root mean square error is still not acceptable. So if we visit again the modification index, so sinasuggest na naman niya na yung educational level at saka work experience, if we connect, the modification index will decrease by 10. So educational level and work. Okay, so just minimize this. Educational level and work experience. Double-headed arrow. Educational level and work experience. It's this one. Okay, then calculate, analyze, then calculate. Paulit-ulit lang siya. Then click the arrow, read arrow. So it is now acceptable. The p-value now is 0.095. The chi-square is 0.709. Then the root mean square error approximation is less than 0.08. Acceptable. GFI is 0.997. Acceptable. In fact, good fit yan. Then CFI is 0.998. Good fit. So, ibig sabihin, yung chi-square natin has an associated p-value of greater than 0.05, which is the acceptable value. The root mean square error approximation, the GFI, the CFI. If you want the other fit indices, you can click view, then text output. Okay. Kapag hindi lumabas, ganyan, nasa ilalim ng ano yan, nasa ilalim ng output, yung icon na to, yung pink. So AMOS output. Then estimates. Estimates, nandyan kung significant or not. Then if you click the model fit, you can see the different values of fit indices, including the GFI, the PGFI, the P, the minimum chi-square, CFI, TLI, marami. Marami yan siya, including the root mean square error approximation, including the AIC. Okay, so including the EECVI, the Quelter. Okay, so yan yung ating fit indices. Then because the fit indices are already acceptable, we can proceed to check the estimates. So the estimates here, especially this table, tells us which path is statistically significant. For example, educational level to Salbeg, ang coefficient na is 0.752, 0.306. Standard error is 38.944. Itong critical ratio, ang ibig sabihin yan ay estimate divided by degrees of estimate divided by SE, standard error. Katumbas siya ng Z sa Z-test, katumbas ng T-test din. So if you divide the estimate by 38.944, the result of that is 19. Then the software can, kung ma-compute na niya yung CR, critical ratio, the software can be able to compute for the P value. So if the P value is less than 0.001, the number that will appear, or yung tatlong asterisk will appear corresponding to the CR, critical ratio. So for example, in the future, you will forget what is the meaning of 3 asterisk. Just click. Yeah. The probability of getting a critical ratio as large as 19.317 in absolute value is less than 0.001. In other words, the regression weight for educational level in the prediction of Salbeg is significantly different from 0 at the 0.001 level. So two-tailed. Okay. Okay, so in other words, we are already successful of this of getting an acceptable model fit statistics. So regarding the for example, ayaw mo yung mga placement nung coefficient, ayaw mo, so you can still improve. Gusto mong i-improve, for example yan, gusto mong i-improve yan. Yan. So ganyan. Okay, so pwede mo i-undo if you want. Okay, so for example, if you want to move the entire diagram, ang gagawin mo lang is select all objects. Then you can use the say for example the cart, pero dapat i-ano mo muna, deactivate muna yung mga coefficient. Then you can use the cart in moving the entire drawing. Then you can deselect all objects. Then click again the red arrow. So this object can be copied and pasted to, can be easily transferred to the MS Word. Copy and paste lang. So mayroon tayong edit, then copy. Then paste it to the Word kung mayroon kang MS Word. So MS Word. Yan. So friendly siya, user friendly. So ang concern na lang natin talaga yung paggawa ng model at saka yung tiyaga ninyo so that you can be able to publish your paper, review of literature. Yun lang. When it comes to data analysis, it is not a problem because we have AMOS. So take note that for today, ang ginagawa natin dito ay observe variables lahat. So tomorrow, next meeting, ang gagawin natin ay yung latent variables. So this is our first model, but of course we need to trim further because there are coefficients that are not significant. So for example, educational level hindi siya significant. Age hindi siya significant. Work to time hindi siya significant. And itong age to time may tendency dito na magiging non-significant yan dahil nasa 0.049, nasa critical point siya. There is a tendency that after the removal of the other non-significant path, madadama yung path from age to time. But conceptually, in principle, ang ating test ay okay na, so we can present these results. Then later on, we can create or we can add, we can insert additional section in the results part of our paper na trimmed model na siya. So let's save us. Let's save first. Save. Then we can save another one, another copy. Save as. Then at this time, ang file name natin dito is PUP model 1, then trimmed version. Okay, so the trimmed version. So meaning to say we remove the non-significant path. So one at a time. So for example, we calculate again. Then we click the view text. Then estimate. So kung ano yung pinakamalaking P, yun ang unahin natin pagtanggal. So the largest or the path with the largest P is H2 Salbeg. So meaning, yun ang tatanggalin natin. H2 Salbeg. So from here, this is the path that is candidate for removal. So click lang natin yan. Then calculate again. Calculate estimates. View text output again. Then estimates. So of course, ang next candidate for removal is the educational level to time. Okay, educational level to time. We can remove that education to time. This path coefficient. Then of course, calculate again. Calculate estimates. Then go to the text output ulit. So the text output estimates. So as you can see, work to time is the next path to be removed. Work to time. So work to time. So this one. Then calculate ulit. So analyze, then calculate. Okay, so click view text output ulit. Then estimates. So we have now our last coefficient, non-significant, age to time, 0.261, age to time. So this one. So in other words, job seniority is no longer an endogenous variable. Hindi na siya dependent variable. So job seniority is no longer an endogenous variable. So there should be no error in prediction. Okay. Then calculate again. So after the calculation, okay, after the calculation, your p-value now is improving, 0.133. Okay. your chi-square now is 9.797. Your root mean square error approximation becomes smaller. GFI is closer to 1. CFI is closer to 1. And the other fit indices are improving. Ganun po yun. Mayroong nagtanong kasi kanina kung mag-improve ba ang chi-square, mag-improve din ang fit indices. Yes. So the other fit indices are now improving. The chi-square, for example, is very close to the chi-square of the saturated model. The p-value is greater than 0.05. The minimum chi-square divided by degrees of freedom is less than 2. So acceptable na siya. The other fit indices are also improving. Sabay-sabayan silang lahat. Okay? So I think I am done with the demonstration. So I will go back to the PowerPoint presentation before we have Q&A. Before we go to the Q&A, rather. Okay, so let me finish first. So maaga tayong matapos dahil I want you to, just in case you are interested, you can utilize your time to go back to the video, then have hands-on with your own if you have AMOS in your laptop. Voluntary lang yun, so hindi naman siya requirement. Okay, so this is our final model. So ito na yung we can add a section, last section in the results section about the emerging model. So this model is different from the framework that you proposed at the beginning. Okay, so if we summarize, finding an adequate model, a model is adequate at a certain level of confidence if the following are met. So the model is theoretically correctly specified. So covariance-based, please take note that covariance-based require us to have a model. Dapat may model ka muna because the goal of the covariance-based SEM is to confirm the model, test the model, or confirm the model. So in other words, our model should be theoretically correctly specified. That's the first requirement. Then the model fit, or the data fit the model. So this refers to the fit indices or goodness of fit statistics. So goodness of fit is evident if p-value associated with the chi-square is greater than 0.05. No evidence of acceptable fit if p is less than 0.05. That's the ideal. But of course, if that is the case, then kung hindi talaga ma-achieve yung greater than 0.05 na p-value, you can utilize the other fit indices. Then correct the model if the p-value is less than 0.05. Okay, so like this is a sample model wherein the this is a sample acceptable model because the p-value is greater than 0.05, assuming na theoretically and correctly specified ang model. Pag sinabi nating theoretically and correctly specified, ibig sabihin yung mga variables mo, yung interrelationships among the variables are correctly connected by arrows in accordance with the review of literature. Okay, so this is an example. The next slide is an example of misfit. So it is not acceptable because the p-value is less than 0.05. And next slide is the guide on how to correct. So if the data misfit the hypothesized model, some corrections in the model are needed. Two approaches of correcting the model. The first is theory driven. Use theory and remove restrictions one by one until the model fits. Ayun actually ang ano natin. Use data at hand to remove restrictions one by one until the model fits. So far we utilize number 2. But in actual research, I suggest you use both. Kung halimbawa, using your data, kung ang suggestion ng data ay ganyan, so validate it using the theory. So number 2, in this approach, theoretical considerations do not matter. The analyst uses clues from the data itself to improve the model. Kaya ang I've been accepting consultation since 2004. Kaya minsan natatawa ako kasi bakit ako ang mag-modify sa model na hindi ko naman alam ang subject matter ninyo. So for example, the model is business. So malay ko ba kung ano ang sinasabi ng literature, kung i-connect mo ba yung one variable to the other. So ang mangyayari, data driven lang ako. So dapat mas maganda alam din ng researcher kung bakit i-connect natin yan, i-check niya, i-validate niya kung logical ba na i-connect yung dalawang box, dalawang variables. Okay. Kasi dapat nga, sabi ko nga, theory at saka data driven. Both theory and data driven. Okay. So for the model correction, as experienced earlier, we always check the modification index. This modification index is the value of or the expected value of chi-square na mabawas if we connect one box to another box. Meaning to say, this modification index is the expected value of expected reduction in the value of chi-square. If we connect one box to another, there is a large or significant change in the value of chi-square if the path that you are going to add is significant. Okay? Kung hindi naman significant, hindi naman i-suggest ng chi-square yon. Hindi i-suggest ng computer. Hindi i-suggest ng AMOS. Okay? So remove the restriction with the highest MI. Meaning to say, remove the restriction with the highest MI. Yun yung i-drawing mo. Draw a line between variables with the largest MI. Calculate the estimates and see if the data fit the model. Yun actually ang ginawa natin kanina. If the data still misfit the model, then repeat steps 1, 2, 3. Ayan yung model correction. Okay, so here we have the identifying number of restrictions. So actually, yung number of restrictions is equivalent to the number of degrees of freedom lang yan. For example, educational level, Salbeg, and salary now are already connected. Lahat naka-connect na, so the number of restriction is already 0. Now, if we remove, for example, the link from educational level to Sal now, the number of restriction is 1. Ibig sabihin, mayroon pang isang possible na arrows na ma-drawing, yung number of restriction. The number of restriction is equivalent to the number of degrees of freedom. Okay. So for example, this one, although na-discuss ko na ito kanina, but we need to repeat. For example, the degrees of freedom is 4. Ito, nakalagay dito. So the degrees of freedom is 4. It indicates that there are 4 restrictions in the model. Ibig sabihin may mga path na hindi pa na-drawing. For example, educational level to current salary, wala kang path. Okay? Age to current salary, wala din. Okay? Then we have work experience to current salary, wala ka ring arrow. Then finally, beginning salary to job seniority, wala ka ring arrow. So ibig sabihin, yung 4 degrees of freedom is equivalent to the number of arrows na hindi mo na drawing. Okay? So yun yung ibig sabihin. Then the software will choose from the 4 kung alin dyan sa 4 ang pwede natin i-connect so that the chi-square will reduce. So that's the goal of that. Okay? So for example, in this diagram, there is MI below. We have the, di ba, 4 yun kanina. So out of 4, 3 ang nilabas ng software. Sabi ng software, age to SALNOW has the largest MI, 43. So if you connect age to, say for example, mag-drawing ako. If you connect age to SALNOW, this arrow, if you connect that, the modification index is 43.976 dito sa baba, this value. So indicating that if you draw that arrow, the chi-square will decrease by 43.976. Okay? So tingnan nyo. So kapag i-drawing na natin, magiging 20 na lang. Earlier, 66.898. Okay? So kapag ilagay na natin yung line na yan, the chi-square reduced. Okay? Then repeat the process. The suggestion of the software is to draw another path from educational level to SALNOW. From here going to SALNOW. Yan ang suggestion ng software. Because if you draw that according to the software, the chi-square will decrease by 8.136. Okay? So you do that, follow that instruction. Earlier, 20.607. Ngayon, na dinagdag na natin yung line, nagiging 4.650 na siya. Okay? So that's the process. Ngayon, ito actually ang ating final model earlier, but of course, we need to trim. We need to trim a model for better fit. So our goal is to produce a model such that all path coefficients are statistically significant. So malapit na ako. So don't worry. Okay. So there are 5 steps. You should follow this. Remove the parameter that has the highest p-value. Re-estimate the model. Check if the model still fits. If the data misfit the model, then reintroduce the parameter. Meaning to say, i-remove mo yung path na yun with the highest p-value. Then recompute. Then check if the model still fits. If the data misfit the model, ibalik mo yung arrow. Yun yung ibig sabihin na reintroduce the parameter. Then if data fit the model, accept the model tentatively and repeat the procedure, starting at step 1 again by removing the next non-significant parameter. Now, this is our last part earlier. Then we start by trimming. So based on the result, ito malaki. Mga non-significant yan sila. Ito, non-significant. This one also is non-significant. Okay? So we remove that until na isa na lang ang natira, similar to what we did earlier. Ito na lang ang natira. So finally, we can remove that. Then we come up with a clean model. This is the clean model that we have. The p-value is 0.133. So the model fits better, greater than 0.05 ang p. The model is parsimonious, meaning to say less number of parameters. All remaining parameters are highly significant. Okay? So, mayroon lang na nakaharang. Okay, so I think we are done with the day one. So it's up to you if you utilize your time for the practice. But my recommendation is you utilize your time. Hindi naman siya compulsory. You still have 2 hours to practice. You can go back to the drawing or to the video in case kailangan. So I provided the data set. Binigay ko na kay sir kanina yung ating data set kay Sir Renato pa. So I already sent to him the link of the database as well as the slides. Okay, so I think I need to turn over the microphone to Sir Sagindan.